Live. There we go.
Cool.
So yeah, seeing a lot of new faces and names this evening, which is really great.
Oh, there we go.
Oh. So it's nice to see you all. Welcome to DevOps Nuts. If you've not been before, we sort of spend this first 10-15 minutes chatting as people sort of filter in as best they can filter in at the moment, I guess, and then we'll kick off at 1:45, if not slightly before, with our usual preamble, and then we'll go straight into Mark. Right. How's everybody's week? I know it's Tuesday, but it feels like it's been a week already.
It does. Yeah, it really does. It's been long. The hour has screwed me over. Like I mean, it's good because I've got an extra hour's sleep, but also my body just doesn't really. It's all confused.
I forgot it changed, to be honest.
Keep waking up at like 4:30 in the morning.
But it's
and like
good
just being like,
you sleep 1 hour more, no?
Yeah, I don't. It's having weird repercussions on my circadian rhythms, I think.
If somebody can explain to my kids that the clocks went back, that would be great.
just mention that it's fairies or elves or something like that.
Yeah, the 4-year-old would see right through me. Or even try and you got to be good for Santa, whatever that does. 4-year-old
in October.
Yeah.
Listen, I'd start it in January if I thought it would get good behavior. But
you've got to get a good run up at it. You know,
this guy's not working. He's too smart.
Oh.
I think it's definitely one of those things where you either don't notice it. So I slept straight through it, didn't even register that it had changed. But now I'm finding that, like, especially on my week off, and I've turned off all my alarms and everything, and then suddenly it's like, oh, that's 10 a.m. or 11 a.m.
Yeah.
The days are just rushing by.
Yeah. The later you get up, the quicker the day disappears. I like to get up early, even on the weekends. Well, I say I like to. I do. But don't always like it.
Do you make a habit of getting? Because I know when you do come to your Nottingham offices, you've got a long way to go.
Yeah.
Do you make a habit of getting up at the time you would get to leave to come to Notts, or?
I did when I was actually coming in, but I haven't. I've been in twice in the past 9 months. Yeah, but yeah, I did typically. But it's getting up at like 4:45 in the morning, so a little bit later. I get up most days, like 6.
I've been leaving it really late. I'm not gonna lie. Like 8 o'clock.
Just feel like the day is wasted.
Well, especially on a working week, like I'll get up, I'll take the dog out, I'll shower and whatever, and then it's 9 o'clock. Do my work day. That's kind of it.
I usually start.
9 o'clock is definitely late, I would say.
I would agree.
It is on a work day for sure.
I think also depends. I don't know, what's your day like? Because if you start 9 o'clock and then you got meetings and things like that, it feels like your day is not that useful. I mean, personally speaking, I find in that. So I either start early or end up doing some work at night, which, to be honest, I think the latter is not that healthy, but sometimes you need to feel a bit useful.
Yeah, I know what you mean. I mean, I think for me, most of my days meetings, pretty much all of the time, in one way or the other. I probably, especially the last few weeks where things have been so busy, I've maybe had hour and a half, maybe 2 hours a day where they haven't been meetings.
Oh.
Do you find that now, because of the COVID-19, is well, I guess I'm assuming that most of you guys are working remotely. You finding that there are more meetings, more like yeah, like, well, I wouldn't say like overhead, because obviously meetings, there are some that are useful, but I think I'm finding personal experience recently is like too much, to be honest.
Yeah, I reckon there's probably, in my opinion at least, there's definitely more meetings that could have probably been an email or a quick conversation on Slack or something. But I don't know if that's also just a symptom or outcome of that we're really busy at the minute as well, or if I feel really busy because there's so many meetings.
Yeah, I know what you mean. Yeah.
I certainly feel like I've had an awful lot more meetings in the last month, Lewis.
And we are not in the same meeting. So, and I think people even people that working in our project, there are some of them they got even more meetings. So I'm kind of complaining, not complaining really, but I cannot imagine other people that got even more meetings. It's like, no, sorry.
I was going to say, welcome to the VMD, Mark. We seem to get a lot of meetings.
Yeah, but Dave, don't you think that this since we started doing working remotely? Because I don't remember having that many meetings.
No, I suppose we used to just do it between our team, didn't we, mostly? And there was like once a week we'd all get together. Whereas now it's just overkill, there's a lot more.
To be honest, I kind of miss the going, I mean, talking about waking up early. I mean, we used to go, in the past was like a night in London. Well, near London, it's not really London. I'm in Southwest, in Exeter. I think, well, Dave, you are not in Exeter. You are nearby, right?
Yeah, I'm just like 10 miles outside of Exeter.
Yeah, and waking up like for me was like 4 o'clock in the morning, just to drive 2 hours to Addlestone. That was, to be honest, that was a bit of a pain in the neck, but I actually enjoy having like a night out. I love my children, but that's also a break. I'll say that before my wife finds out.
The thing for me is it was quite more productive having meetings in person, wasn't it, before COVID? So just the 2 days in a week in the office was quite beneficial because you get in a meeting room, get around a whiteboard. And I think the whole remote thing doesn't quite work the same.
Yeah, that's true. Although some people said, I mean, I know that some of our colleagues, they said that at least you can have a meeting and you can do something else. But to be honest, and that's true, but sometimes you do that something else and actually you're not paying 100% your attention to the meeting. And
yeah, you're right though, isn't it? It's like one of those things where if you're doing something else in the meeting, it would be the same in person. If you're doing something else in the meeting, you're not paying attention to what's going on in the room.
My wife had this issue with her team, and then they started to enforce webcams, which really sorted that issue out. So we don't use webcams. Yeah, we don't use webcams at the VMD. No one seems to want to use them, but I think by enforcing them, people can't just, if I'm sat here doing this now, it's obvious what I'm doing.
I don't know if I would be keen with webcam, to be honest. My setup is a bit well, I don't have the webcam is on my laptop and my laptop is on the right and I got the two screens on the left. So that's why when I join you guys, I have to, I mean, all the time. So if I want to see you, I have to always look there and I cannot look straight. So obviously, yeah, a portable webcam will do.
I say invest in a webcam, Luis.
No, I know they're quite expensive.
You're a contractor.
And also, yeah, I'm a contractor, but still, I mean, £200 for a webcam.
It's a business expense. What are you on about?
Exactly.
Still,
I'll wait for you, Luis.
It's still. I don't think I will make the most of it. And the other thing, don't you find that there's some problems with the microphone? Because lately people have been having problems with the microphone because they got like integrated microphone and Skype adjusts the settings, and sometimes we cannot even hear you, Dave. You know, you have to join again.
If I go on mute on Skype and then go back, I seem to be really quiet. I have to leave the call and rejoin.
The thing that I'm taking away from this is that you use Skype still.
I know, it's terrible. We're trying to move to Teams, but that's proving more difficult to get the guy to set it up right. But
Yeah. So what do you use? Zoom for web conferencing?
Yeah. Yeah, we use Zoom at ours.
I use
and then Teams.
We've got
Zoom.
Teams, Slack, Zoom.
I say we currently have Slack, Zoom, Slack, Skype, and Teams. So we're trying to sort of get everybody onto Teams. So we just have one.
I've got what we got. We've got Zoom, Slack, because it depends on the client as well. Teams, something called Blue Jeans, which I've used all of once. Some people who still use WebEx.
Wow.
GoToMeeting, things like that. Yeah.
GoToMeeting, yeah.
Is that what that is? Oh, I know what you're talking about.
There's just so many, so many just sat running all the time. But yeah. Hello, folks who have filtered in over the last few minutes. So we'll give it a couple more minutes and then we will get a move on. And we can go from there. I did end up using a new one recently because I can't remember how I came about using it, but ended up using Amazon Chime, which is like Amazon's internal teleconference thing. I'm not quite sure why they decided that the right thing for them to do would be to write their own rather than just use an off-the-shelf. I mean, they can't hate Microsoft that much, surely.
It's probably that's got an excuse to sell the Amazon video stream stuff.
Yeah, straight, yeah.
Yeah, that's how they, I think, introduce their normal workshops and other things. It's outside world, so.
Cool.
There's a thing called AWS Connect as well, which is a full telephony system in the cloud, which they've been trying to peddle recently. It's only just become available in local regions. It's been in America for a while, but you can get it in Germany now, I think, as well.
Oh, that's pretty cool.
Yeah, it's quite a big offering that they've got going. So I'm not surprised they're doing smaller projects. You know, if they're doing a full a telephony system.
That's to compete with Microsoft's offering as well, isn't it?
Yeah.
Because Skype's now full telephony as well, isn't it?
Yeah. If it ever works.
My wife.
Yeah, I mean that's the barrier to entry.
They implemented it in Devon County Council across the board, and they seem to have got on quite well with it. It seems to work really good.
What amazes me is that Teams works so well, yet Skype seems so flaky. And I thought they were basically the same under the hood. I thought they'd reused a lot of the Skype technologies to build Teams, but maybe they haven't.
Okay, folks. So let me just sort out the right portion of my screen because Zoom decides that the sliver that it wants to share is not great. And we can get going. So welcome to October 2020's DevOps Knots. This time last year, we had a Halloween special, but unfortunately, it's quite difficult to do that for once we're all remote this time round. But let's get underway. As always, we've got two fantastic speakers for you, but I'll come to that in just a second. And again, it's really nice to see a lot of new faces here and a lot of our regulars as well. As always, a huge thanks to our sponsors for making the meetup possible, even in the times now when we are completely remote. We've got Rebel, who provide our Zoom. We've got Stickers, who provide sticker packs. And if you would like stickers sending out to you, just drop us a DM on Twitter and we can sort that out for you. And of course, we have JetBrains, who provide us with a license key to give away this evening for 12 months of subscription to any JetBrains product that you can lay your hands on. And even when that 12 months expires, if you choose not to renew it, you get a previous version of your chosen product in perpetuity as well. So if you can't get enough of hearing myself or Misha speak or the rest of our sort of group of people, you can listen to us anytime you like on wherever you get your podcasts now, really, for the Agile Engineering Podcast. Our latest episode was on the Agile Principles, and we have one coming out next week on Friday, where we talk with Tom Hoyland, who's spoken here at DevOps Knots a couple of times and has been on the podcast to talk to us about the theory of constraints. So, as I mentioned, we have a giveaway this evening for our JetBrains license. For those watching on YouTube and those here in the meetup, all you've got to do to win this JetBrains license is send us a tweet with the hashtag DevOpsNots. And just because it is Halloween, let's make it a little bit Halloween themed around around your cloud adventures. So we'll pick a winner at random at the close of the meetup this evening. We are now also looking for speakers for 2021. I'm sure, as you know, if you've been before December, we don't have a meetup, and we have I think we have speakers for next month. We're just waiting to finalise the second one, but we are now looking for January through to November in 2021. So if you want to have a go at speaking at a meetup, be it remotely or through a webinar or whatever, we can take our time, sit with you and take you through that and get you on board into speaking next year. Just drop us an email at contact@devopsnots.co.uk, or you can also drop us a message on Twitter as well. At this point, I'm going to hand over to Misha as a literal message from our sponsors.
Hello, everyone. I'll keep it short. We have a lot of roles on, which is great, given that the pandemic was not kind. AWS and Azure platform engineer roles, SRE roles, which is particularly good. I'm sure Liam would agree. Cloud engineer roles from all kinds of levels. So just give us a shout if you are looking for a new role.
Yeah, in particular, the SRE role is one that I am recruiting for at MMT Digital. If you're interested in that, drop me a message and I'm more than happy to have a conversation with you around it as well. So, on to this evening's events. We have a fantastic lineup of speakers, as always, for you. We have Gregor Suttie and Thomas Thornton coming to speak to us about deploying Terraform via Azure DevOps. And we have also got Mark Jones to come speak to us about building choreographed microservice systems architectures with actual lessons learned from the trenches as well. And with that, let's give a big warm welcome and round of applause for Mark as we will hand over to him. Welcome, Mark. You're still muted, Mark.
I can see that, but I had all sorts of screen sharing windows on top of you that was trying to... Right, there we go. Okay, thank you everybody for joining. Hopefully you can now see that on my screen. So yeah, I've come today to talk to you about microservice architectures, particularly choreographed microservice architectures, and some of the patterns and the architectural principles that I've learned as I've gone along doing this for the last 6 years or so now. I've built architectures around microservice patterns now in 4 different organizations. And I guess, you know, you learn things as you go along the way. And so what I wanted to do today was effectively share some of those thoughts with the teams and just show people what it is that I've learned, really. Okay, so feel free to add me on LinkedIn if you like what I've talked about. I'm quite happy to, you know, have more contacts. Okay, so let's get started then. The things I'm going to talk to you about tonight in terms of microservice architectures are largely based around 2 different people and the work that they've done and building, you know, effectively on the shoulders of giants already. In particular, the book Building Microservice Architectures from Sam Newman informs an awful lot of what I've done over the last 6 years, but also there's an important concept that I've embraced that was first put forward by a guy called Fred George, who you may or may not be aware of. He's an agile speaker. He talks at a lot of big events. I believe he's an original signatory to the Agile Manifesto back in 2000. And one of the talks that he did back in 2015 or so heavily influenced the architectures that I've built over the last 6 years. So moving on then, what exactly is a microservice architecture and when is it appropriate? Well, I think the appropriate thing is a really good question. The thing with a microservice architecture is, of course, that it's very popular at the moment. It's a good buzzword. Everybody's looking for this new idea of decoupled microservices. And it all sounds really great. You know, we've all suffered the problems of monolithic architectures and the complexities that they carry along with them. But it is fair and it is true to say that a microservice architecture is not always appropriate. Some problems simply aren't complicated. You know, and a microservice architecture is really for solving large, complicated problems. So if you are literally just building something that needs to read a record from a database and display it to a user, you really need to consider whether a microservice architecture is an appropriate approach. You know, we know how to build end-tier applications. We've been doing that for a very long time, and they are often an appropriate approach to the problem at hand. So don't dismiss them just because there's this new thing called a microservice architecture. The other thing I would say is if you identify a need to reuse bits of your modules, bits of your application across the business for different purposes. If you've seen a lot of reuse of your services and of your APIs, then that might suggest to you that you are indeed looking towards going to a microservice architecture. And what I mean by that is, you know, if you've got a set of APIs or a set of components that are common across a number of applications, then that might be an opportunity to start looking at a wider, more loosely coupled architecture. And I think you need to be honest about your business as well. You need to think, you know, can we handle this? Has the team got the skills and the capacity? Is the business mature enough? Has it embraced Agile to a thorough enough degree to ensure the success of a project like this? So again, you know, be honest with yourselves. If you don't think that the team or the business can handle it, then it may well not be appropriate. I wouldn't want to advocate building an architecture like this, only to learn that ultimately, you know, that you've built a real big mess that nobody can handle. So it's important that you get good DevOps practices in place. It's very important that you deal with things like continuous delivery and ensure that you understand how to build things and deploy them quickly. And I would advocate dealing with all of those problems up front. Don't leave them until the last minute until you actually want to deploy something. I would design all of those kinds of systems in terms of your build controls, your versioning, and all of that right at the beginning of your project so that it's in place when everything starts to go through and you're building services that are flowing through your pipeline. Another good point to make is that it's all about trying to embrace agility. So if you are in a situation where your business has got a lot of changing requirements and situations like innovation teams or people that are doing a lot of market testing and you don't really know what it is you're building yet, you're still trying to kind of discover what it is that the market is looking for, then a microservice architecture may well be appropriate because it provides you with that nimble ability to effectively try new things, remove things that aren't working for you and just continue to change your system around the architecture as you go. And another good reason to approach it, but again, I think, you know, bear in mind my third point around can your business handle it, is are you experiencing maintainability issues, scalability issues, or agility issues with your current product? If that's the case and you can't scale your application or you're finding that actually, you know, you're suffering system entropy because you've been building this product for 5 years and you've had a lot of churn in your development team and nobody really knows how it all works anymore, then this might be an opportunity for you to think about the lessons learned, the mistakes that have been made by monolithic architecture and whether it's appropriate to move to a microservice architecture. But if you are going to move to a microservice architecture, I highly recommend that you establish some good principles of microservice architecture design. Now, I've done exactly that, basing almost everything that I'm about to show you off of the book, Building Microservices by Sam Newman. And so here are a few of the principles of a good microservice architecture that I've developed over the last few years in various different companies that I feel will lead you towards success. The first and most important, I think, is to understand what a bound context is. In Sam Newman's book, he makes a big thing about bound contexts, and that's what you're supposed to be building your services around. And I think it's an important distinction to realize that a bound context and a domain are not necessarily the same thing, and understanding exactly what that difference is. In applications I've dealt with, I feel that a domain is a much bigger concern in which a number of microservices may participate to provide an answer, whereas a bound context is usually the thing around which you're writing a service. Now, it might be that within your traditional application, you have a database, a relational database, and you have a page on your website that maybe joins 3 of the tables together and displays some of that information. Well, if that's the case, what that might tell you is that actually those three tables, those three pieces of information belong together in a context. And that context is the UI. It's the contextual interface that the user is using into your system. And so actually the UI design can often give you the answer as to what your bound context should be. A good microservice architecture should be entirely platform and technology agnostic. I'd say entirely. There are, of course, technology decisions that you have to make, but it's important to try and make technology decisions that lead you very open to the future. Docker is probably key to that in the modern world. It's obviously, it's a technology that effectively provides us a layer that we can put our applications in and then make them portable across a number of different platforms. And whether that's an on-premise Docker cluster or an AWS or Azure cloud technologies or something else entirely, whether it's managed or whether you're managing it yourself, the point remains that if you're targeting a Docker container, you can remain completely agnostic of the platform that you're going to be running your services on. And if you're looking at technologies like NetCore, then of course, or any other programming language that's available on a lot of different operating systems, then of course you can still move across operating systems and different platforms at will. It also means, though, that your services that you develop need to consider other ways of being agnostic. Are you using message queuing or databases? And if you want to swap them out in the future, what would you choose to couple yourself to in order to ensure that if you did want to swap those technologies out, that you had that a layer of abstraction in place to ensure that you could do that. Obvious things are things like saying, well, okay, any AMPQ AMPQ compliant message queuing system would be appropriate for my product, or any key value store might be appropriate for my product. And then if you're clearly defining the technology that you're trying to target, you can swap the actual implementation underneath that at any time. One of the things that Sam Newman talks about a lot in his book is choreography over orchestration. There's a whole chapter over it, and understanding exactly what that means, I think, is an important part of a good design. The difference and the distinction is actually very easy to understand. Most systems, as we understand them today, are orchestrated systems. And if you imagine an orchestra is led by a conductor, and that conductor tells every participant in the orchestra when to start, when to stop, when to increase in volume, when to decrease, when to speed up, when to slow down. They effectively tell and conduct the entire system, and that is how orchestration works. We have a component within our application. Very often, it's the standard sort of anti-pattern of the God object, that something in the system is the central component, and it calls out to the other components in the system and orchestrates the behavior of the rest of the system. Choreography, on the other hand, is much more like a dance. If you choreograph a dance, then each participant in that dance knows their steps. They practice them over and over and over again, and they can do it with their eyes closed. And ultimately, if they can all do it with their eyes closed and they are dancing on a stage together, so long as they know their moves, they can go in time with the music. It doesn't matter what everybody else on the stage is doing. They're able to complete their task without the input of any other dancer. And so that's the kind of system that we're trying to build with a microservice architecture, a choreographed system with every microservice independent, capable of doing its own job without having to depend upon knowledge of other domains or other bound contexts that belong to other services. It's about doing its own thing in isolation and doing it effectively. And so to achieve that, one of the biggest principles to follow is every microservice should own its own data. And what that really means is you need to be very strict about joining data in any other place. I would generally treat a microservice as a state machine for its data. If I want to do anything with that data, I would go through that service, whether it's via its message bus or its API endpoints or whatever it provides. The point remains that you should do it through the service and let the service manage the data. And in doing so, you can embrace patterns like code first in your database technologies. You can do things like migrations, and you can control everything from the service. And I would say that's a philosophy that you should try and aim for with everything else that you do. Try not to build things into third-party systems. Own the logic, own the business logic of your system. So if you are using RabbitMQ, don't spend a lot of time configuring the exchange and all of the routing keys and the different keys that you're going to need. You could write scripts to build all of that, or you could just have every service create its own queue when it first spins up and remove the queue if necessary when it shuts down. The point remains, own that logic in the service itself. But if you are going to then, of course, have a lot of different microservices all controlling their own data, doing any kind of reporting across your system becomes quite difficult because, of course, all of the data is in different places. And the last thing you want to do is send huge requests into your system that are going to tie all of your services in knots, going and fetch in big chunks of data, only to try and join all of that together somewhere and report that back. So instead, don't report on your microservice architecture. Offload reporting as a concern elsewhere and ensure that that's where you do your reporting, just like you would in any other traditional application. All of this, as I said a few minutes ago, requires you to address your cross-cutting concerns up front. So things like your build pipeline, your microservice framework, or your service chassis, or whatever you choose to call the thing that allows you to create your services quickly, and everything else, your environments, anything else that you need to build. Get it all, try and up front, make sure you know exactly what it is that you're trying to do before you go ahead and do it. And in particular, look for the cross-cutting concerns. So if you are going to build a microservice chassis that will allow you to effectively drop business logic into that as a project, then you would want to make sure that you're addressing things like logging, metrics. You want to make sure that you can host API endpoints or any other threads that you might need to do. Probably want to put in health checks and anything that you would say, this is something that absolutely every one of my services has to do in order for it to be a mature service as part of my system. So as I say, you do need a very mature CD continuous delivery process. Another thing that is a distinction of a microservice architecture, and one of the reasons why a lot of companies look to embrace it, is the idea that you can scale each of these components independent of any of those other components. So deal with auto scaling as well, and put that in as part of your microservice chassis. You understand that how that's going to work right from the beginning and up front. I've already talked a little bit about each service having no knowledge of other services, and the reason that you do that is because otherwise what you have is something called implicit coupling. They may not necessarily have any knowledge of anything else in there, but if they're sharing some kind of object, or if they're sharing some knowledge of what that other service is supposed to do, they're implicitly coupled. Another really good example of an implicit coupling is when two applications are using the same relational database, which of course has a schema. And if one application requires a change to that schema, then you immediately impact the second system, and the second system also has to be updated, despite the fact that it probably had no change in business requirements. So try to avoid having to change other systems because you've changed one system. That's any way that you do that. If it's not a direct coupling, it's clearly an implicit coupling. Try to support multiple versions of your services running at the same time as well. It's very easy with things like ingress networks and modern technologies like Kubernetes and Docker Swarm to be able to host multiple versions of the same service as API endpoints. And equally, you can do things like run different instances of queues for different service versions to ensure that you're effectively processing the same data in both services, but giving two different answers back. And I think there are a number of patterns that can be employed within a microservice architecture that ensure that you can run multiple versions of your service. And that gives you the ability to roll back if in a disaster situation, but also, of course, the ability to do things like A/B split testing, blue-green deployments. But more importantly, it contributes very strongly to your ability to keep your service loosely coupled from each other. If I have to make a change to a service and that then has a cascading effect on other services, then I've not I've not achieved that loose coupling that I was trying to do. So if I want to update a service and I can deploy a second version of that, and now any caller of that service gets back two answers, a version 1 answer and a version 2 answer, well, then the responsibility for taking that new version of the response lies on the original server, the requester at that point. And they don't have to take that new version of the response immediately. You are decoupling the teams from each other, allowing one team to work on one service and increase its version number, potentially introducing breaking changes, yet ensuring that anybody working on that second service doesn't have to take those breaking changes immediately. One very flippant rule that I've thrown about there over and again a few times over the years, and I'm not going to be absolutely strict about this ever with anyone, but it really is sort of a mindset thing. If it takes more than 2 weeks to throw away one of your services and rewrite it, was it really a microservice? And I think that's a question that you can always ask yourself, if this thing is getting too big, does it need to be split down? And I wouldn't ever have that as a hard and fast rule with anybody. But as I say, as a challenge to a team or anybody that's looking to rewrite a service, that's something I would certainly throw into the mix. And all of this really is intended to support what I've called low friction development. The idea that if you can encapsulate all of your continuous delivery pipeline and all of your cross-cutting concerns for your services and get them out of the way quickly, then what you've achieved is effectively a situation where your developers only need to focus on business logic. That gives you very low friction development. No longer does every developer need to spin up a new MVC project, worry about whether they need to wire up the logging, and every other thing that you repeat over and over again every time you start a new project. If that's something that you have to repeat every time you start a new microservice, it will soon get tedious. So encapsulate that as part of your cross-cutting concerns. Protect yourself from third-party systems as well. One very obvious way of doing that is the circuit breaker pattern, which is advocated in the microservice book. And what that really means is that if a third-party dependency like a third-party API was to go down and your calls to that started failing, back off. Just keep on checking it, queue up your messages that you're wanting to send, and ultimately when the service comes back on, then you can start to send those back through again. So try to employ any dependencies on third-party systems with things like circuit breaker patterns. Just protect yourself. In the microservice book, Sam Newman challenges the concept of dry. Do not repeat yourself. And of course, it's a very common idea among us developers that we don't want to repeat code, that we want to, encapsulate that in things like shared packages. But Sam Newman does point out in the book that then each microservice is not independent. If you have a shared package that all of your microservices are dependent upon, then of course they are intimately coupled. And while I do agree with that in principle, I think in practice, it's simply unachievable in the languages that I've worked in my career, particularly in C# and .NET Core, where most of my time has been spent over the last few years. And I think that it's an interesting philosophy to approach, but actually, if you are following good practices around how you manage your packages and ensuring that you're doing things like open close principle to ensure that you're not breaking things that you already have in there. If you can do things like use the obsolete attribute on top of your methods and classes, then you can inform consumers of your package that you are deprecating code and cause warnings in their compilers. There are all sorts of things you can do in order to manage that shared code base and ensure that you're not introducing breaking changes to it and that everybody can kind of upgrade through that gently. You will, of course, always find something that's going to force you to update every single service when you release something into your shared package, but that should be the exception and not the rule. And I would script for that. Ultimately, it's just a package reference. You can just update your project files with a new version number. So if you do need to update all of your services in one go because you've introduced a breaking change to your cross-cutting concerns package, then I would do that through a script. So what does a microservice architecture tend to look like? Well, this picture is not mine. I've pulled this off of the internet. And this is a good example of the kind of microservice architecture that I've seen advocated a number of times by different luminaries within the industry. Have a sip of water and I'll let you digest that a moment. The thing to note here is that all of these services are communicating via REST APIs. But ultimately, they all seem to be able to call pretty much any service. There doesn't seem to be any upward or downward rules on who can call what. And for me, although you can manage this with things like service discovery, ensuring that services, particularly, you could have a service registry where you say this service offers this data type, and that any time a service wanted a piece of information of a particular data type, they would ask the service registry for an endpoint they could call for that data type. You can do things like that, and but you are ultimately introducing coupling. And what I do feel that you are largely going to end up within a system like this is you are going to tend towards an orchestrated system. There will be certain components that simply the central part of your system. And if you imagine any database design that you've ever come across, there's always one table in the middle that everything else is connected to. And I think you're doomed to repeat that same kind of mindset with an architecture like this. So what can you do differently? well, I'm going to move back a little bit and talk about the kinds of things I've just talked about a moment ago on the cross-cutting concerns. So if we're going to do a different architecture, what could that look like? First of all, address those cross-cutting concerns, avoid the loose coupling, ensure that you capture the things like health, scaling, configuration data, queue communications, API authorization, metrics, documentation, API hosting, logging, all of that. I'll come to that data tributary one in a moment. Make sure your cross-cutting concerns are in there. Then how would you manage a number of different microservices and ensure that the versions are going? Well, one thing that I've found is probably a bit of an anti-pattern is trying to follow the Git flow branching strategy on a microservice. The reason I feel that it's an anti-pattern for a microservice is we have to remember where Git flow as a pattern came from. Well, first of all, Git itself was developed to manage the Linux kernel, which is probably one of the biggest code bases around, and certainly one of the ones with the most contributors and the most complicated set of branching going on. So it's a very big and complex source control system that's capable of doing a lot of things. And the Git flow branching strategy was largely created to try and manage that kind of complexity. What we're talking about is a monolith across, whether it's more than one repo or not, it doesn't matter, but it is a monolith nonetheless. If we're not building monoliths and we're only building small services and we want to be able to release them very, very frequently and very, very regularly, potentially multiple times a day, do we really need a complex branching strategy as complicated as something like Git flow? And I don't think you do. I've advocated a number of times now a very simple branching strategy that releases from master. It uses a branch on release strategy rather than a branch for release strategy. And what I mean by that is that you take a branch when your master is ready for release. And it may be that you just tag that and commit. You may not need to take a branch. But it's important that a different concept from branching for release, where you create a branch and then you get the release ready on that branch and push it out and merge everything back to master. Branching on release is a much cleaner pattern, and it allows you to keep it's all about keeping master as your releasable branch. And what I've got here is an example of how you do semantic versioning through a branching strategy like that. So in effect, every branch that you create increments the minor version number, but it doesn't do so until it actually commits back to the master branch so that you get it in sequential order. And then every commit that you do to a branch increments the patch number. The major number, because that indicates a breaking change, is very difficult to automate. And so what I would do with the major number is ensure that you have rules around being able to bump the major number through your build system so that when you do so, it would deploy a new instance of your service. As we said, you want to be able to run multiple versions of your service. But it's always going to be a manual thing that the developers have to do because they're the only ones that really understand when a breaking change is being introduced to the system. So what does your continuous delivery pipeline need to look on a per service basis? I'd say it needs to look something like this. It's very straightforward. You push a new feature branch to your source control repository, probably a pull request through Git, and then you immediately do your unit testing, your build, your static code analysis, and things like that. Obviously, you merge to master, and when you publish your image, your container, or whatever it is that you're actually going to be deploying to your production systems, you publish that, and again, you run all your unit test, build, static code analysis. And then you work through a pipeline of environments where you perform different types of testing until ultimately you make it through to production. Now, what I've tried to represent here is that ultimately you have a number of different pipelines, so a number of different services all going through the same process. It may well be that you can get to a true continuous delivery pipeline where each one of these flows straight through to production and you're able to release immediately to production. But most of the companies I've worked for are probably a little bit concerned about doing that straight off of the bat. And so what I would advocate is having some kind of stopgap. Now, this gives people a lot of control over what they can and can't release. What I would suggest is that you effectively have the ability to manually promote either individual services or all services in an environment to the next environment. And that gives you the ability to either push through individual services if you're doing things like hotfixing or you're trying to get closer to continuous delivery. But it also gives you that control, particularly as QA departments want, to be able to ensure that everything is working in an environment and then take that environment wholesale over to the next environment. So I think that that's a very easy thing to implement with tooling such as Jenkins and Visual Studio Online, TFS and things like that. And I'd certainly recommend doing that. So I'm going to carry on talking a little bit more about this example architecture and what that really needs to look like. So ultimately, you're going to have a continuous delivery environment that basically
they broke in a car around the corner. So close they were.
You're muted, Mark.
Okay, I'm not sure what happened there. Where did I get to? I was carrying from the beginning of the slide. So effectively, you're going to have a continuous delivery pipeline that's going to pull your code from your repositories. It's going to publish images, and then it's going to push those images to your Docker environment, whether that's a Kubernetes cluster, Docker Swarm, or whatever else you choose to use. What that really means is that you're going to need some kind of ingress controllers that suck those HTTP requests in and put those and route that traffic to your services within your Docker cluster. So I want to talk to you now about some of the patterns that I've worked with in order to try and deliver microservice principles. The first one is the needs and solutions pattern, and it's the key, I feel, to doing a choreographed system. So the needs and solutions pattern comes from Fred George, who I mentioned at the beginning of the talk. And if you Google him, you will find a video on YouTube where he gives this talk. And about an hour in, he starts talking about how you can place, how a service can express a need to a message bus and then receive a number of solutions back from other services. Now, he doesn't actually get into any kind of implementation detail on what a needs and solutions pattern might look like, but the principles and the ideas behind the needs and solution pattern certainly came from there. And it was myself and a colleague called Matheus about 6 years ago back at Experian that kind of developed this idea of using a JSON object to pass around between services to be this needs and solutions thing. So what can this choreographed architecture look like? Before I get onto that, though, I just want to mention a couple of these other patterns. So in order to get the data out of microservices and do the reporting question, I'm going to also talk about the data tributary stream lake pattern that I've sort of advocate. Also, I would like to talk to you about the idea of inversion of authorization. And then I'm going to talk to you about two very standard known patterns that are largely to do with dealing with legacy systems and how you can use these patterns to migrate your legacy applications towards a microservice architecture. So the needs and solutions pattern and what a choreographed architecture might actually look like. So first of all, it's important to understand that if you want every service to be able to see every message, the simplest way of doing that would be to use a queuing system with a fan-out message exchange. Every service can then simply send a message to the exchange and replicate that to every queue where services can pick that up and make a choice as to whether they can process that message or not. What you would then want to do is ensure that when a service can process that message, instead of responding to it, that it simply decorates that existing message with further information and places it on the exchange for other services to be able to see. So in effect, every service is expressing needs and they are receiving back solutions from other services. And those solutions may or may not be composed by a number of other services. In doing so, though, of course, there are a number of challenges with using a fan-out message exchange. First of all, if you choose to do this asynchronously, your messages will grow exponentially, and you would have to deal with lots of duplicate messages going across the queue. Even in ordinary operation, this kind of architecture will use duplicate messages going across the queue. Equally, it means that every service has to pick up messages that they're not interested in, that there is a lot of wasted processing time and effectively disposing of messages that are being sent that that particular service can't process. And so it's not without its issues, but for me, the problems that we face with a pattern like the needs and solutions pattern are the cost of having that agility within our system. I would also ensure that you split your queuing down into domains, have a separate exchange and set of queues for every domain that you want to do. And this naturally fits a lot of the processing of a lot of different organizations. Quite often we will ingest data of some type, whether that's a user filling out a form on a website, or whether we're receiving telemetry from an aeroplane or any other kind of incoming data. Effectively, what we have is a pipeline where incoming data needs to be processed, ingested, and probably decorated with some lookup data before then finally moving into a processing domain and doing, the actual work of whatever it is that we want to do with that particular data that's coming in. And just because I've created an ingestion domain and a processing domain on this diagram, don't by any means think that that's what I would design in a real world scenario. You will need to design your domains around the problems of the business. And it may well be that processing is actually broken down into a lot of different domains. If you're lucky and your business is only really dealing with a few web forms and the users are largely filling those out, and those are your sort of incoming events, then you probably don't have a big system to build. But for a lot of organizations that are dealing with complex problems, this is generally the way that you would want to split this architecture apart so that you can deal with things in isolation, in effect. And what you would have is a service in between domains that's capable of recognizing when a message is mature enough, when it's gathered enough information to be passed to the second domain. So what might a message contract that supports such a architecture look like? Well, I briefly mentioned earlier that I feel it should just be a JSON object. The reason it should be a JSON object is actually really simple. It's easily understood. It's just a string. And so you can digest that and consume that with literally any programming language or technology on the market. And it doesn't have to be a complicated message. I'd certainly use the concept of a correlation ID for any kind of message that is continually decorated and has a long lifetime, so that you can monitor the evolution of the message as it progresses through your system and understand what services have interacted with it at what times. Equally, you might want to include things like user information in there. Messages that are crossing your system are ultimately the things that are happening. They're the most important things that are happening in your system. And if you're wanting to create some kind of audit trail, then you may want to be able to pass information along inside the message in this sort of meta header data that allows you to do that audit trailing. Putting information like the source service or the last modified by service is actually really useful. You don't necessarily have to have these things, but if you are building a system where services are continually being duplicated and picked back up again by the service that last published that message, well, it gives you quick and easy ways to dispose of messages. So what I would look to do in your microservice chassis or your framework that you choose to build is that I would look to try and implement that kind of quick, fast checking of any message coming into my system and try and dispose of a message as fast as I could so that I didn't waste too much time doing that. And what that might mean is trying to use the header information rather than trying to deserialize part of the inner objects within the message itself. There's a property there called the event, and I find that this is potentially an alternative to using split domains. You could use the similar concept to using a routing key in RabbitMQ, and you could just use a routing key in exactly the same way. Having the routing key here, though, follows the microservice principle of trying to own your code and ensure that you're not baking things into configuration in third-party utilities. So it's very simple to, again, every microservice simply check the domains and the events that they're interested in for those domains and filter out anything they're not interested in very quickly. The important part of this, though, of course, is the need and the solution object. And very, very simply, they are simple JSON objects that can be any shape. And if a microservice can deserialize that object, then it can process the message. If it can't deserialize it, then it's clearly not a message that that microservice understands, or it's the wrong version, or equally, something would need to be updated in that service in order to be able to consume that message. And the solutions are exactly the same. It might be that if you are in a chain of events, that actually the initial need might be to create a new user account. And that in creating a new user account, you put a solution on there. But actually, once you've created a new user account, maybe you need to register them with a whole pile of third-party systems and do all sorts of other things. So there may well be other solutions that get populated into the message as it goes around your system. And it may be that actually a service doesn't have all of the information to provide a complete solution, and that only after the message has been decorated by a partial solution can a second service then pick this message up, having seen that it's been partially decorated, and supply the remaining bits of information for the solution to be complete and the original requester to be able to finally deserialize that object and consume it. And I think that's the simplest way of ensuring that the service that originally requested the information gets that information back, is that they have to understand the schema of the solution that they're expecting. And when they do finally see a message with that schema, they can simply deserialize that and use that object. So that's the needs and solutions pattern and how you might build a choreographed system. But of course, in doing so, we've introduced a number of other challenges, in particular the reporting concern. So how might we start to address that? Well, that's where the data tributary, stream, and lake concept comes in. So a data lake is not a particularly well-defined concept within the industry at the moment, but what we do know is it's basically a large store of data. And that we want to do something with that data. In general, they're kind of seen as the starting point of a big data strategy. And what you generally do from them is treat them a lot like a data warehouse, in that you probably do ATL jobs off of them and create data marts that you can then do specific reporting around specific domains in. So how do you get that information there in the first place? Well, again, it's a cross-cutting concern. So build it into your microservice chassis. If every microservice that you build from your microservice chassis then duplicates any data access that it does, or in particular, any update, create, or delete of its data into the data stream as a one-way operation, then you can have all of that information duplicated in the lake. Any change to that data state is going to be replicated to that data lake. And so you have effectively a source of truth that you can report on. This means that your microservice has become about answering operational, what is going on now concerns, rather than historic concerns. I'll offload the historic questions to the reporting infrastructure. That's what it's there for. The data tributary can be absolutely anything. You can use a true streaming technology like Kafka, or you can just use an S3 bucket. It doesn't really matter. Resilience is probably key more than anything else. And then all you're going to have is a simple script to ingest that data from from that stream into the lake. And that can actually be very, very simple. Data lakes, if a wide column store is used, for example, you can have the concept of column groups. And so what you can say then is any service that's sending down a JSON object of type user, well, clearly we're going to create a new column group called user and take those properties and place them in there. And you can do the same thing with every object that each microservice passes. And that way you get in your wide column store a representation of the entities that exist in your microservice architecture, but it's largely loosely coupled from them because it's reading the schema of the message and then inferring the column structure from that. And that gives you the ability then to update the schema of the data that you're storing in your microservice data store, and your data tributary stream and lake remain resilient to that change. I briefly mentioned the concept of inversion of authority. Now, this is a problem that I first came across quite early on when I wanted to understand how I could authenticate and authorize API endpoints across a microservice architecture, in particular because, of course, it's a distributed system. If you look at something like MVC, in general, when we're dealing with authorization, we're encouraged to decorate our controllers and our action methods with roles in effect, and we often hard code those roles in, those names in there, in order to ensure that the people that are trying to access those HTTP endpoints are authorized to do so. What I would suggest doing is building authorization as a service. If you offload the who is allowed to perform the activities of an API endpoint or the actions of that API endpoint into a service, then you can simply request at service startup time the roles that are authorized to perform the activities of those API endpoints. What this means is, of course, that you've decoupled your microservice from the authorization architecture, and it can change at any time, which allows you then to build a full management system around your roles and permissions that effectively feed in at service runtime to the API endpoints. So rather than try and bake it into your microservice, bake in the access to the authorization service that you build and put that into your cross-cutting concerns package so that every microservice simply needs an authorization service in place for it to be able to continue, for it to be able to do its authorization. It's often useful to turn authorization off in development environments as well. If you're building an authorization and authentication based microservice system, then of course you're building a number of different microservices that potentially supply that. And then when the developer is running this stuff on his local machine, he'll have to run that entire infrastructure as well. So it might be worthwhile that you bear in mind that the developers don't necessarily need to do all of the authorization at all times when they're doing day-to-day work. So find ways to switch that kind of stuff off. Try and embrace feature switching as much as you can. So that gives us the inversion of authorization. What I'd like to do now is just finish up by talking to you about a couple of very simple patterns that have been well known for a long time that are largely about dealing with legacy applications. The first one is branching by abstraction. The idea in branching by abstraction is you have two components. Component one talks to component two, and you need to introduce some kind of change or replace component two on the right-hand side. And so what you do is you introduce an abstraction layer, and then you pass through every call that you want to make to that service on the right. You pass it through, and you just pass it through. You can pass back the response. You don't actually have to do anything. It's literally just a pass through. But then gradually you start to peel away bits of functionality and rewrite them in a new version of the service. At this point, your abstraction layer can then redirect requests from the caller to the new version of the service. But equally, it can push requests to the old version of the service if that piece of functionality hasn't been implemented yet. And then, of course, I'm sure you've guessed the rest of it. You take away the legacy application, and all of the calls then go to the new version, and then simply remove the abstraction layer, and you've replaced the application. A very similar approach would be to use the the strangler pattern. The strangler pattern is very, very similar. Again, you have two services. The one on the left is trying to use the functionality of the one on the right. So we introduce an abstraction layer. But this time, instead of introducing a new component like the one before, what we do is we actually start to swap the responsibility, and we rewrite the functionality in the abstraction layer that we've introduced, effectively strangling off communication with the old application, at which point it can simply be removed. Okay, finally then, to finish up, I'm going to talk about a few of the lessons learned that I've come across as I've been building microservice architecture. Some of these are mistakes that I've made myself. Some of them are mistakes that I've seen other people make. But the point is that there are mistakes that can be learned from, and I'm hoping that by explaining them to you today, you also won't make these mistakes as you continue on your microservice journeys. The first one I would term as avoid N-tier thinking. You're not building an N-tier application anymore. It's not a database, a business logic layer, an API presentation layer. Those kinds of applications, or rather, sticking with that kind of thinking will lead you to build a microservice architecture that also fits around that N-tier thinking. So one example that I'm aware of that I wouldn't repeat is the idea of splitting APIs away from their actual back-end services that hold the data. I think that's a mistake that I wouldn't make again, and that I would avoid in the future. And that, I think, is largely thinking about the application from a technical perspective and not looking at it properly from a bound context and domain perspective, and encapsulating all of the layers of the application within that bound context. Equally, try to avoid request-response thinking if you're building an orchestrated system. Request-response thinking leads you to the point where you're simply depending upon another object for more information and continually calling that other component for more and more information. Again, try to encapsulate everything within the bound context of the service. If you are encapsulating everything within the bound context of the service, you don't need to make request responses. And if you are using a message queuing system and a choreographed approach, or more importantly, a message that's continually decorated and grows over time, that is not a request response approach. And so don't treat it as such. Treat the messages as evolving over time, and each service is only capable of participating with that message once the message reaches a particular maturity that that service can consume it at. Equally, avoid the relational or normalized entity thinking. And what I mean by that is don't build your microservices around what would have ordinarily been a relational database table. It's very, very easy to think, okay, we've got users, we've got orders, we've got sales. Let's build a microservice for each of those objects. That's probably not the right way of doing it. Think about what the bound context looks like from your user's perspective, or whoever that actor is on the system, whatever the user stories that you're looking at, and think about the context from their point of view. I'm going to bang this one home again. Build in to your framework, your logging, your metrics, your hosting, your authentication, data access, configuration, all of that. Build it all in upfront as much as you can. And try to build reusable CD and CI pipeline components. Jenkins and TFS, Visual Studio Online, and any mature continuous delivery platform will give the ability to write shared components. If all of your services are based upon the same framework, then it's only configuration that you need to change on a per service basis. So you build reusable components and just pass configuration and store all of your configuration in your continuous delivery environment. Finally, embrace feature switching. I think I don't need to talk much more about that. I've talked a little bit about running multiple versions, but also running multiple versions of your API endpoints through whatever ingestion mechanism you're using, whatever ingress you're using. And finally, my last point is one-way dependencies on legacy systems. One of the biggest mistakes that you can make is to build a new system that immediately calls to your legacy system to retrieve data. Ultimately, your legacy system is still the master of everything that is going on. So try to flip that dependency every time you can. Try to ensure that the dependency is one way and that legacy systems depend upon your new system. And that way you will tend naturally towards the strangler pattern of building more and more functionality into your new applications and less into your legacy applications. I don't know how far over or under I've gone, but that is it. Thank you very much for listening.
Fantastic stuff. Thank you very much, Mark. So as good a round of applause as you can give for Mark, please.
Woo!
So does anybody does anybody have, either on YouTube or here in Zoom, any questions for Mark at all, please? The YouTube a second to catch up as well, because it's always a moment or so behind. I guess in the meantime, Mark, I've got one. So when you're trying to stay, I guess, vendor agnostic, is there not a risk there of almost engineering the solution, or even going down the route of making it too expensive to build to stay completely agnostic? So let's say, I don't know, if you wanted to stay, if you want to stay agnostic in terms of cloud provider, so Azure or an AWS, for instance. You muted, chap.
Yeah, so I'd say obviously you need to stay pragmatic with these things. Sometimes it's about costs, sometimes it's about trying to do the right thing in terms of the technology, and you have to make the choice based on the business. What I would say is that actually you do need to make choices. You do need to lock yourself into technologies. You will have to choose a queuing system. You will have to choose a cloud provider or whatever it is that you do. But try to build things in a way that you can replace them at a later date. So if you are wanting to commit to using AWS you've got no intention of moving that, introducing something like Docker as a containerization technology allows you to maintain that portability and swap over to any other infrastructure that can support Docker should you choose to move so. So where you do want to make your technology choices, they're in places that try and open up the possibilities rather than lock you into particular vendors. The truth is, though, you do, of course, have to lock yourself into vendors. Everybody chooses either AWS or Azure or Google Cloud. You do make a commitment to that. But how committed you get, how deep in bed you get with them is important to understand, because the implication is if you ever need to get out of that, how much have you got to unwind?
Okay, thank you.
Quite a lot of bullet points of things that I just don't know what they are. If I, I mean, this is the role I tend to play on the podcast as well, where there might be some people that don't know the things that I don't know as well, so maybe it'll help someone. What is system entropy?
System entropy, so like universal entropy, basically the entropy is the idea that everything kind of slows down and gets more and more locked up and more difficult. So in terms of a system, I guess the best example is introduction of new technologies by a new team. You start to build something, everybody's really into it, everything works really well. Gradually over time, you get a bit of team churn, more and more people come in that don't understand the original philosophy of the application. Mistakes get made around the original intention of the architecture, and so things start to get coupled together. And within any monolithic application, what you tend to start to find is that when you try to make a change to one part of the system, it starts to have a cascading impact on other parts of the system. Yeah. As that gets worse, as the application continues to get older and more stuff gets put in and more developers churn happens, that's what I describe as system entropy, that eventually the system gets to a point where it's so expensive for you to make any change to it that the entire team basically ends up turning around to the business and says, we just need to rewrite it. And in my experience, that's kind of a 5-year cycle. Microservices as a philosophy is there to try and solve that problem.
Cool. Like something that I was thinking about, I've literally today just finished an audiobook, the Unicorn Project, which I've been meaning to listen to for ages. And for anybody, I'll link to it somewhere. But it really demonstrates like a lot of the stuff that you've said in that book. About like but it's really good. It's from like a human kind of point of view, which naturally, you know, not a kind of computer scientist myself, it's really interesting, like to see the knock-on effects on like on a team of like how you, if you decouple a system, then you can free up the team and everything that you were saying. So yeah,
when it's done right, it works really well, but it does require that maturity.
Yeah. If nobody else has any other questions, I've got a lot of
I got a question for Mark. So related to the design of the microservice architecture, I mean, I to be honest, I don't have experience around that because I never worked on a microservice architecture, but I really like the idea of each microservice to own everything, because that actually it kind of built as well a bridge into the developers to think not just about the functionality, but also about other concerns, because I think developers tend to think about, okay, the functionality is ready, the tests are ready, that's it. But they don't, when it comes to infrastructure, when it comes to being production ready, that's something that there's a big gap. But there are some areas that I think there's always a bit tricky to achieve. It's like, for example, I think there's in one of your slides is about auto scaling, and obviously when you use a technology, or if you're trying to be technology well a bit agnostic, so it can be reused and portable. I think, for example, if you take something like Kubernetes, where the main concern for Kubernetes is you got the scheduler that knows where it needs to auto scale and things like that. I don't know how that will play well when it's actually the microservice saying, I want to scale up, and actually that might not be possible or not best practice.
Well, it depends on how you choose to approach it, doesn't it? If every microservice has access to the Docker daemon and says, I want to scale up and can run a command to do that, then it's perfectly possible to do that. Or you could encapsulate that as a responsibility in of itself and say, here's a scaling service, and that when a service wants to scale, it asks this service to do that for me. And that one service then can run on Docker manager node and have access to the daemon in order to perform the scale commands. Or sorry, Kubernetes, or whichever technology you're choosing to use in order to that has that scaling built in. I wouldn't advocate trying to replace the built-in Docker or Kubernetes scaling. I would try to build upon it and then think to myself, well, in my particular scenario, what is it that is an indicator for my service that it needs to scale? It might be that it's high CPU or memory usage, or it might simply be that there are 2 messages in the queue and I can't process them fast enough. But if you're dealing with that within your own code, you have the option to make those kinds of choices and then use, and as I say, build upon the technologies that you're working with in order to do that auto scaling.
Yeah, thank you. Makes sense.
There's what do you call it now? Just so on the Kubernetes thing, there's is it CADA that's now like coming up to version 2, I think, and that's Kubernetes event-driven something. I can't remember what the A stands for, but it means you can now trigger scaling based on a whole other range of metrics and events as well, I think.
There you go. This is it. And there are always new things coming out, so staying on top of it all can be challenging.
Yeah, for sure. Any other questions, folks?
This might be really dumb, and I apologize if so. What is a cross-cutting concern?
A cross-cutting concern within the context of what I've been talking about tonight is something that every service needs to do. So it's is something that I would ordinarily repeat it over and over again. So for example, if I'm going to write a web application, I'm going to end up having to write something that hosts that application every time. I might end up writing a startup class or something like that.
Yeah.
And in every application, I'm going to repeat that same piece of boring work.
Yeah.
And do that. That's the
fair.
concept, actually. So what I'm talking about within the context of this talk, a cross-cutting concern is anything that every service is going to have to do to be a mature enterprise-grade service in your environment.
Cool. Thank you.
Okay, folks. Well, if there are no other questions at this point in the evening, so let's take a quick comfort break, and we'll return in 5 minutes, so 5 to 8, and we'll pick up with both Gregor and Thomas. In the meantime, folks, please remember that there is a giveaway going on, and here's a fantastic slide that I threw together in literally the last 5 minutes, and you can't tell at all that's what I did. So we'll take a quick break, grab tea, coffee, gin, beer, pizza, whatever you desire, and we'll pick up at 5 to. Obviously, feel free to stick around and chat in the meantime. We'll still continue broadcasting on YouTube. But yeah, that was a fantastic talk, Mark, and thank you very much.
Yeah, that was amazing. Thank you. Can't believe how many people are having pizza. Making me very jealous. I hope your Cabernet Sauvignon's good, Mark.
It's Tuesday as well, isn't it? Could get Domino's.
Yeah, I really could.
My
I'll
wine's
go for Domino's. Huh?
My wine's nearly gone.
Excellent.
I did have a look. I've got, although it's going to make me sound like an alcoholic, but I've got 14 bottles in my little wine fridge thing.
Oh, I thought you were going to say standing on a wall then.
No.
One green bottle.
Is it the one bottle you've had to yourself this evening, or are we saying the glass?
I had a glass yesterday because it was my birthday.
Yeah, happy birthday.
That sounds really weird that I had a glass yesterday and then I've drunk the bottle now. But yes, I've been trying to be off it for a while. I've been going to a personal trainer, and she keeps shouting at me every time I come with a hangover.
Well, tannins are good for you. Sorry?
I've just been trying to cut it out, but it's my birthday, so sod it.
Yeah,
exactly.
Yeah, I think you deserve it.
Whereas Misha's sending me links to gin advent calendars.
Yeah.
That said, it's like the Black Friday deals thing already on Amazon, so I wonder if it's on that.
That is a very good point.
I've just been looking at that myself to see what booze-related things there are.
Probably shouldn't tell people about it though, because then there won't be any left. But there is an excellent gin calendar, advent calendar on old Amazon.
Really like how when you do search for it on Amazon, you start typing in gin advent calendar, and then the second automatic suggestion is gin advent calendar adults, as if there's one for kids.
We're not in France.
Which one of you highlighting?
Sorry?
Which one are you highlighting out of these gin calendars?
There's a few.
There's one with Whitley Neal gin in it, and it's all different.
It's the first one. It's the black one. Hang on, I will grab a link.
Yeah.
No, don't show everyone. There won't be any left. I need the gin.
Where's the chat? There we go.
Yeah, I found. We get a nice cocktail recipe book as well.
Ooh. I like cocktails. I make a lot of cocktails.
Still working through that gin that I bought tail end of last month, where I got that chocolate orange one that looks a bit like chocolate milkshake, and the slow roasted pineapple one.
Still haven't got any of that. I can put it on my I'm going to put it on my Christmas list. Because no one will get me the advent calendar because it gets given before Christmas. So, yeah.
The weird thing about that advent calendar, when you click through to it, it has a subscribe and save option.
That's true. Yeah.
Every month it says most.
Oh, wish it could be Christmas every day. Now you can, it can be December every month.
I mean, I'm just saying, if anybody from Whitley Neal is watching over on YouTube,
yes,
we are open to sponsorship discussions.
I love you, Whitley Neal. Thank you. Right, I'll be back in a sec.
Okay. Yeah, but Wesley, if we bought it now and we bought one for December based on the subscribe and save, we can do it for most of November and December.
True. You get £10 off if you do the
subscribe and save. Well, what do you need to do to get the 15% off? Save 15% when you schedule repeat deliveries of 5 or more in one delivery.
Having an advent calendar in March seems. Wow. Suppose it depends how long lockdown's going to last.
That is true. I mean, yeah. What part of nuts are you in, Mark? I'm in the Rushcliffe bit, so.
Actually, I'm quite lucky. I actually live in Hucknall, so I'm classed as Ashfield.
Right.
I'm staying tier 2. In your face. But yeah, we're still not going anywhere. So
yeah. Okay, folks. So a couple of more minutes, and we will pick back up with Gregor and Thomas. Once again, thank you to all our speakers this evening for taking time out of your evenings to come join us, and to you, our attendees, as well. I know it's not quite the same as it was this time last year, but your continued attendance obviously makes it worth Misha and I are still organising this every month. And I think when we looked, we're one of the highest attended meetups in Nottingham, and that's really goes to show how great our community is and how great the caliber of our speakers are. So hopefully we'll continue that into 2021 as well. Right. So as it is 5 to 8 at this point, I would like to hand over to both Gregor and Thomas for their talk on deploying Terraform via Azure DevOps with some awesome features. Please take it away, gents.
Cool. Cheers. Thanks, Tim. I'll just share my screen now. Cool. Is my screen sharing okay?
Yeah, all good.
Cool, awesome. So tonight's talk, myself and Gregor is going to be talking about deploying Terraform via Azure DevOps with some awesome features. And just before we jump into that, we have a quick introduction. So I have 10 plus years experience in IT, and I come from a sort of on-premise infrastructure engineer background. And in the past 5 years, I've spent my time in Azure and really utilize the sort of DevOps culture where pretty much a lot of teams are utilizing nowadays. And I also blog all things Azure and blog my sort of findings and troubleshooting and things like that on thomasthornton.cloud. So I do recommend you checking that out as well. And I also have an active Twitter and LinkedIn following, so do give me a follow.
Hi folks, my name is Gregor Suttie. I'm from Glasgow in sunny Scotland. Just want to say a big thanks to Liam and Misha for inviting us on tonight. And thanks everyone for attending, much appreciated. Just also want to say great job in the first talk, Mark. thoroughly enjoyed it. It was really good. I know it was your first talk, so well done. That was really good. So I've got 23 years experience in IT, mainly as a developer and DevOps background. I'm currently an Azure architect for Intercept, which is a company in the Netherlands. I'm an Azure MVP and a Microsoft certified trainer. I also help organise the Glasgow Azure user group. And my daily job consists of designing, implementing and optimising customer environments. And we also get to do customer workshops, which is great. My blog's at gregorsuttie.com. It's mostly on Azure. It's got some Azure DevOps and some DevOps things in there as well. You can find me on Twitter at Gregor_Suttie. In tonight's session, we're going to try and make this interactive. So if you have questions, Thomas is going to be doing most of the talking. I'll keep an eye on the chat. And if you have questions, just type them in the chat and I'll ask them. I'll stop them and ask them as we're going. I'm also going to ask questions because I don't really know much about Terraform. So we're going to hand it over to Thomas. So Thomas, go and kick us off and let's get started.
Sounds good. Yeah, so tonight's agenda is going to look like this. We're going to start off with what is Terraform, so a quick introduction of Terraform, and then moving over into the sort of Terraform workflow, and this will include the core commands within Terraform, and how you would go from initializing Terraform to actually deploying Terraform, and deploying Terraform to actually have some Azure resources, and then moving that into Azure DevOps. So DevOps, for anyone who's used it, or Azure DevOps, it's massive. So tonight we'll be covering Azure repos and Azure pipelines via code. And then that brings us into deploying Terraform into Azure using Azure DevOps as well, and also some demos on that. So we'll dive into the pipeline creation at quite high level, and then look at more pipelines via code, and then have a sort of a workflow from how we can go from develop to production to DR, and also introducing build validation, and also testing your code using Inspect. And also at the end, there's plenty of time for questions. And as Gregor mentioned, if anyone has any questions throughout, just give me a shout. So what is Terraform? Terraform is a tool for building, changing, and versioning infrastructure safely and efficiently. So Terraform's template-based configuration files. It enables you to define, provision, and configure Azure resources in a repeatable and predictable manner. In theory, it is easy to read, it's decorative, and it's driven via the Azure API. It's also open source, so it's free. And all this automation, it really does have several benefits. It lowers the potential for human error while deploying and managing infrastructure. And it gives you the ability to deploy the sort of same template multiple times to create identical environments. So say if I was looking to develop or create a develop environment, I can use the same template to create production again, and even DR. And I'll also show that in my demo of how I would do that, and utilizing the sort of TFRs files within Terraform. And then Terraform's great. So as the resource, or as your sort of Azure estate grows rapidly, and the sort of resource topology becomes more complex, understanding the meaning and impact of infrastructure changes can be difficult. So this is where Terraform, it really helps you to understand any infrastructure changes before they're actually applied. And the Terraform CLI itself, this will help you because it allows you to pretty much plan and preview any infrastructure changes before they are applied. And using Terraform Plan, it has several benefits as well. Because if your state or your Azure estate increasingly gets bigger and bigger, team members can collaborate more effectively and even more efficiently by quickly understanding proposed changes and their impact, all from viewing the Terraform plan. So any unattended changes are pretty much kept out of your environment and caught during the development process.
Thomas, quick question.
Yep.
So I'm used to using Azure ARM templates to do this. What's your thoughts on the main benefits of using Terraform over just simple Azure ARM templates?
Yeah, the main, I suppose, Terraform and ARM, it is plus and minuses. ARM sort of Azure specific, where Terraform, you can sort of deploy it into any cloud provider, but whenever you're creating templates, you would deploy it most likely for one provider at a time. And if you've used ARM at all, it's JSON, so complex JSON templates are not fun at all. Whereas Terraform is more it's more user-friendly, more readable. And then also as well, the Terraform has a sort of state, and where ARM templates, it doesn't. Where Terraform, if you run a plan, you can actually see what you're going to change or what you're going to remove or what you're actually going to add. Whereas ARM templates, it's pretty much, in theory, all or nothing. It will just run the ARM template, and if your deployment is incremental, it will deploy over the top. Or if not, it can pretty much nuke resources and redeploy again, which is definitely never fun. And also as well, a good benefit of Terraform, it has the ability to pretty much clean up your resources, so you can run Terraform destroy, and where ARM template doesn't have that. So yeah, the Terraform workflow. There are 5 main commands within Terraform. With any sort of Terraform deployment, you start off with Terraform init. So it pretty much initializes and allows initializes a Terraform working directory. From there, you would want the plan. So Terraform plan. And this generates and shows an execution plan. So whenever you're happy with the plan, you would then run Terraform apply. And this pretty much builds or changes any infrastructure which is deployed into Azure or even AWS or any other cloud provider. Then there's two other commands as well, which are pretty common. Terraform output. So it reads an output from the state file, which you can actually use if you're sort of using Terraform to modularize. You can take the output from a module and use it elsewhere, and then Terraform destroy. So it pretty much says what it does in the tin. It will destroy any Terraform infrastructure. So that's taken from Terraform state, and it will just pretty much nuke. So up on the screen as well, let's have a look at a little journey. So like any sort of application you're writing or any sort of code, you're always going to edit. So you write your Terraform configuration just like you would write any sort of code in the editor of your choice. And it's also common practice to store this in a version controlled repository, even when you're working as an individual, because you can see changes, you can revert changes. So it's sort of get strategy there. And as you progress from editing your code, you would then move into Terraform plan. So once you've started adding additions to Terraform code, you'd want the plan. Plan will also initialize to see any sort of errors you're having or make sure the code is in a correct state. And then you can review your plan. And once you're happy with your plan, you can then move to Terraform deploy. So that's the final stage. And once you deploy, this is where you're sort of deploying your infrastructure. And then as a continuous loop, you go back to edit more code, you would plan, and then you would deploy. So this is the sort of core workflow. And the next time you want to make changes, you would always start this process over again. So notice how closely this workflow is sort of, it parallels the process of writing any sort of application code. And this is the process, or this is what we mean whenever we talk about Terraform enabling infrastructure as code. So once you've started writing some Terraform and enabling infrastructure as code, there is many, many benefits to that as well. So let's have a look at some Terraform terminology. I'm sure if anyone who's used Terraform, they will know this sort of slides through the way. So Terraform terminology, I've got four quite main points up there. So providers. Providers, they represent a cloud provider or a local provider, but nowadays it's mostly represented as cloud providers, so AWS and Azure, the two sort of main ones. And then within that, providers offer resources. So these are invoked to create or update infrastructure locally or in the cloud, and in this case, or in most cases, it will usually be in the cloud. And then the data sources, so these are additions to resources as well. So for example, if I was looking just a reference of a blob or Azure storage account or some properties within that, I could most likely reference the data source. Nowadays, there's quite a lot of data sources provided as well. And then state, I actually have a slide later in my deck on Terraform state. So state itself, it's a representation of the infrastructure created or updated by Terraform. So every time you run a plan, it will look for its current state and then pretty much reference that and see what has changed or what's going to be removed, stay the same, or even being added. So let's have a look at some Terraform code. On the screen, I've got a main.tf. So that's the sort of general naming convention you would have. So your main.tf would store the multiple resources that you want to deploy. Or if you were going to sort of modularize in bigger environments, you would reference multiple modules inside here. And then you have variables and also TFRs. So let's have a quick look. Up at the top, I'm firstly going to create a resource group, calling the Azure RM resource group and giving a name that Terraform knows of TAMOps. And then inside that, I'm pretty much giving it 2 properties, so my resource group name and location. And as you can see, it's referenced var for each, var.location and var.resource group name. And then also I'm adding some tags. So using a key value of environment, I'm just implementing var.tag. And then moving down, the Azure RM storage account. Again, the name is going to be a variable, so storage account name, but this time I'm referencing the above resource, so the Azure RM resource group that I've pretty much going to be created above. I'm referencing that specific one, and then I'm taking the name of that. So I'm going to deploy my actual storage account into that resource group. And then moving on down, location is going to be a variable. And then because I'm looking to deploy this in the, say, multiple environments, I'm keeping some properties actually static. So account tier is going to be standard throughout my environment. Application type, kind, and also I'm actually deploying a static website as well, just using index.html, and again, adding more tags. So if we move over to the variables.tf, like any sort of, or quite a lot of programming, you'll have reference to variables somewhere, and these are all strings with a description for each. And this is where the sort of, how can I deploy into multiple environments using the same sort of main.tf. I've actually demoed in this and showing TFRs being utilized, but if I was deploying develop production DR, I would have TFRs referencing that. So I would use all the same variables, but have different names to them. So location, say develop there is going to be deployed into UK West, whereas production could be UK South. Storage account name, not DevOps, dev.sa. Production would be the equivalent, and so on. So if you get to just having multiple TFRs file and one sort of main.terraform reference is definitely the recommended way.
Thomas, is this?
Yeah.
Are you using something like Visual Studio Code here? Is that where you normally edit your files in?
Yeah, you can edit your files in any sort of code or any sort of developer tools that you want. VS Code, Visual Studio. Yeah, VS Code is definitely recommended nowadays. It's free and there's multiple add-ons for that.
Yeah, has that got Terraform extensions that you can use to kind of generate code quickly?
Yeah, it definitely recognizes Terraform, and there's multiple extensions out there that can get you off and help you along the way in relation to even, indentation. There's various extensions even for that inside VS Code. I can show some of these later, or I can actually provide them at the end.
One other quick question I see in chat: Where do you store your TF state file?
Where do I store my TF state file? I'm actually coming on to that next. So yeah, TF state. In theory, you would, well, if I was deploying locally or developing locally, if I was just deploying a simple sandbox or something within my Azure subscription, I could have my TF state sitting locally. But then if this brings me into sort of remote state, working within a team or deploying into sort of cloud and using Azure DevOps, you would have a remote state. So if I go through this slide, it will cover this as well, and where I'm actually storing my state, and it's actually remote. So as mentioned, Terraform, it must store state about your managed infrastructure and configuration. So the state itself, it's used by Terraform to map the sort of real world resources to your configuration. And this keeps track of metadata as well. So within big environments, it increases the sort of performance. And sorry, the performance of Terraform, not the performance of your environment itself. So this state, as I mentioned, by default, it's stored in a local file named terraform.tf state. But this is not the sort of recommended way if you're ever working in a team or any sort of remote work. You would have that sitting remotely. So in my examples and in my demos, I have my remote state sitting inside an Azure storage account, inside a blob container, which my Azure DevOps pipelines will reference that, and it will pick up the state and see what is going to actually change and things like that. So Terraform itself, it uses this state to create plans and to make changes to your infrastructure. So prior to any operation, Terraform, it does pretty much a refresh to update the state within the real infrastructure. And then if I was running a plan, it would output the changes to that. And as I've mentioned so far, the primary purpose of Terraform state is pretty much to store the bindings between objects in a remote system and resource instances declared in your configuration. So when Terraform creates a remote object in response to a change in configuration, it records the sort of identity of that remote object against a particular resource instance. And then coming along, if maybe in another pull request, that could potentially update or even be deleted. And again, the Terraform state will be updated to reflect that and any future configuration changes. So Gregor, hopefully that answers your question in relation to where the sort of Terraform state lives.
Going to be annoying. I've got one other quick question. What happens if your Terraform TF state file gets corrupted? What's your options for restoring, or what do you do if your state file gets corrupted?
You start crying. No, no. In relation to that, there's multiple ways. It depends on the environment and depends on what you're actually deploying as well. You can sort of rebuild the Terraform state, or you could just redeploy as well. If it's something like develop, you could just recreate the Terraform state. So there's various options, and there's no sort of one way sort of fits all. Okay, and then production, you can sort of rebuild up again. You're not really going to start redeploying production environment. And that gets trickier again, depending on the size of the environment and how many sort of moving parts you have within your pipelines as well.
Cool.
So yeah, I've talked quite a bit there about Terraform, and hopefully everyone has a good introduction into Terraform for anyone who hasn't used it before. So let's have a look at Azure repos. As part of Azure DevOps, and for anyone who hasn't used Azure DevOps, it's a hosting service hosting service platform which provides development and collaboration tools. There is a free tier to get you started, and you can sort of run pipelines using the Azure sort of free agents to quickly get you up and running. And to be honest, nowadays there's quite a lot of tools available in relation to that. Also as well, Azure DevOps, it's pretty awesome. So tonight we're going to, within Azure DevOps, we're going to be using Azure repos and Azure pipelines. So the repos will be used for the Git, or Azure repos, it's a Git repository. So it'll be used for source control. And Azure pipelines will pretty much be mapped to that repo and download the code and deploy the Terraform in the way I'm looking at. And also as well, there's custom dashboards to pretty much view reports and build builds and releases and metrics as well. And I'm using Inspect at the end of my deployment to pretty much test what I've deployed. And I'm actually publishing that into Azure DevOps, which I can show as well. It's pretty awesome. And let's have a look at Azure pipelines. So Azure pipelines, it's a cloud service part of Azure DevOps, and it lets you pretty much automatically build and test your code project and make it available for others to use. And it works just with about any sort of language or project type, not just for deploying infrastructure, applications, all cool things like that. So Azure Pipelines itself, it combines continuous integration and also continuous delivery. So CI/CD to constantly and consistently test and build your code and ship it to any target. So within tonight's environment, I'll be using Azure Pipelines to deploy my Terraform code. I'm going to take us on hopefully a journey, starting from a manual deployment and how triggers and automation CI/CD. So going from develop to production and ending up in DR with pretty much one click of a button. And pipelines themselves, you can configure them using the Azure DevOps portal, but tonight we'll be using YAML as well. And also any sort of, and jumping a little bit too quick, but the demos as well, they're also all on GitHub, which I have a link for at the end of my slide deck.
Thomas, is there a free version of Azure DevOps that people can use?
Yeah, well, it depends what you're defining as free in relation to, say, repos and things like that. And then you have so many minutes a month in relation to build agents. So I can't remember the free tier, the minutes per month offhand. But yeah, to get you started and get you introduced into Azure DevOps, there's a lot of free bits as well. Azure boards, things like that, but that's more sort of agile and moving into working with teams and collaboration. So Azure pipelines via code. You, like anything, if you're working with code, you would define this in sort of a repository format or in a Git sort of format. So you define your pipeline in a YAML file within your repo. So for example, Azure pipelines.yaml. And then this YAML pipeline is versioned the same way as the Terraform code would be. So the sort of practice of this, if I had a pipeline for develop and a pipeline for master, or sorry, a pipeline for production, I most likely want to keep them all in master, or have the final state sitting in master. And then when I'm building my pipelines, I'm building the pipelines all from master, so the sort of end desired state. And as I have up in my slides, we'll look at some cool pipelines and repo additions in relation to that as well. So some additional info on Azure pipelines. So we've covered the basics of Terraform and Azure pipelines, and how an Azure pipeline is created using YAML. So some more info on additional components that we'll be using within Azure pipelines. So how do the pipelines run? Pipelines can be manual within Azure DevOps portal, or you can create a trigger to tell a pipeline to run, or you can actually configure the pipeline to run upon a push to a repository. So for example, if I was doing a pull request in the develop and it has been approved, the develop pipeline can be kicked off automatically, and that's the sort of integration or the start of your CI/CD journey. Or you can even have pipelines configured at scheduled times, so a nightly build or a weekly job, or even upon the completion of another build. So in my examples, once the production pipeline has been completed, the DR pipeline will be kicked off automatically after production has had a successful completion, and DR will also build as well. So variable groups, these are pretty awesome. I have a slide. I've actually got a slide in them. So these are used to store values that you want to control and make available across multiple pipelines. So for example, if I had a variable group for develop and production, and depending on the group initiated in the pipeline, it will determine which environment it deploys to. So this sort of keeps my Azure pipeline idempotent and generic, and then I could deploy the same pipeline to 3 different environments, and all depending on the variable group that I'm declaring. Also, approval gets, I'll actually show this in production. So this can be used for pre-deployment and post-deployment conditions within a pipeline. For example, when the Terraform plan is successful, this can be reviewed, and an approval kit, so an email can be sent off to a group within Azure DevOps, or a user or multiple users, and the plan can be reviewed. So for example, before I deploy into production, we can review the plan, and once I'm happy with the plan, I pretty much approve it, and then it will go off and run the next next stage of my pipeline. So that would be the apply, and apply the updates to my environment, and trigger. So as I mentioned, trigger is something that you set up to tell the pipeline when to run. So pipeline breakdown, I'm not going to go the sort of deep dive into Azure pipelines tonight. That can be quite complex. So I have a couple of examples here. You organize your pipelines into jobs, and every pipeline has at least one job. And then a job, it's pretty much a series of steps that run sequentially. And then your pipeline may have multiple stages. So point 2, multi-stage, with pretty much multiple jobs. And in that stage, you would use the stages keyword. So let's have a quick look. The single step, the sort of most basic pipeline you could have, it's referencing a pull image. So I'll flip into and just returning me hello world. So a simple bash echo hello world. But moving on down, multi-stage. So for example, stage A and B here. Stage A could be your Terraform plan. And within that plan, I could be, well, you would be initializing, and then you could be, well, you would plan, and then from the plan, I want to zip that plan, build an artifact, and then publish that artifact. So whenever stage B is ran, the Terraform apply, it would download that artifact and pretty much extract and then apply what has been in the plan. And the reason you sort of work with artifacts rather than just having the straightforward continuous. For example, if I was having approval kits, and depending how busy your environment is, but if there was multiple people, for example, contributing to Terraform, and there was a change to go out prior to the one before, you could sort of quite get muddled up. So this is where whenever you're packaging up and having that at the sort of pipeline stage, the artifact, so per pipeline, that's specific to that actual pipeline. So I could have multiple pipelines sitting there waiting to be deployed. And so let's have a look. Pipeline triggers. So you use triggers, as I've mentioned, to run the pipeline automatically. And Azure Pipelines, it supports many types of triggers. The three sort of common triggers are, the sort of major one is PR triggers, so pull request triggers. And as mentioned, causes a pipeline to run whenever a pull request is completed and merged into a branch. Then schedule triggers, so it works with cron syntax, and you pretty much schedule a pipeline when to run, and you can have multiple schedules within that pipeline. And to finish off, pipeline triggers, so you trigger one pipeline after another, and you add a pipeline trigger to pretty much run your pipeline upon the successful completion of the triggering pipeline. So let's have a quick look. Oh. Yeah, the PR trigger. So whenever there's been a pull request, pretty much has been merged into, or whenever it's been merged into develop, there's a change in develop, so that will go off and actually trigger develop and trigger the develop pipeline to run. And then moving on to schedule triggers, I have two cron related tasks in here: a daily midnight build and also a weekly Sunday build. And as you can see, you can actually include different branches as well. So for example, my daily midnight build is be develop, but could be multiple branches that sit within inside develop on a weekly. So sort of more of a cleanup job. And then pipeline triggers. So the pipeline itself, the source, this is the source pipeline. So once it's been completed successfully, it will go off and run the pipeline that sits within inside this as well. And it will include the master branch. So I'm not going to go into sort of the breakdown of variables. It can be quite complex, sort of what comes first, the chicken or the egg sometimes. So variables, it gives you a convenient way to get key bits of data in the various parts of the pipeline. The most common use of variables is to define a value that you want, or that you can then use in your pipeline. And all these variables themselves, they're stored as strings and are mutable. So the value of a variable can change from run to run or job to job, depending on your pipeline. And Azure Pipelines, it supports three different ways to reference variables: macro, template expression, and also runtime expression. And each syntax can be used for different purposes. So when you define the variable, in multiple places with the same name, the most locally scoped variable wins. So for example, if a variable is defined at the job level, it can be override at the stage level, and so on. So it's definitely worth recommended to review your variables and have a look at variables and automation in relation to that. So variable groups, as I've mentioned before, they're great, and I use them throughout my sort of pipelines I create. So use a variable group to store values that you want to control and make available across multiple pipelines. So you can use your variable groups as for example, to store secrets and other values that you might want to be passed into your YAML pipeline. In relation to storing secrets, the variable groups can actually be linked off to an Azure Key Vault. So the secrets are all pulled from the Azure Key Vault, and the variable group, it just stores the, say for example, the secret name or the key name. And to use a variable from a variable group, you add a reference to that within your YAML file. So let's have a look. At the top of my pipeline, I'm pretty much declaring a variable group, not DevOps production. And within variable groups, that sits within the Azure pipelines. So within Azure DevOps, I've created a variable group, and I've added in several variables inside here. Things, for example, like I've hidden Azure client ID, client secret, and you can see subscription ID, the tenant ID is hidden, and then environment. So I'll actually show later why I'm using variable groups within my environment, and I definitely do recommend looking at variable groups as well and how it's referenced within pipelines. So it's a simple reference here, and this is a bash script, and implementing or including two variables into my bash script. So now it's demo time, and let's hope Azure DevOps is all good and I have no issues. So what's going to be covered inside my demos? we're going to look at Azure pipeline deployment with Terraform, and then we'll look at multi-branch triggers. So as I've mentioned, going from develop to production to DR, and I don't want to validate my code in the main pipeline. What can I do? Well, we can look at build validation. I'll add some simple build validation. So during a pull request, it will go off and run a build pipeline, or pretty much a build validation pipeline in relation to Terraform initialize and plan. So during the pull request, I can confirm that my Terraform syntax is correct, and whoever's doing the pull request can actually review the plan to see the change before it actually goes into develop. And can I test what I've deployed? Of course, and we will touch briefly on inspect, or inspect Azure, and it's pretty awesome. So let's have a look at the demos. If anyone any questions so far before I fire up some demos?
No, I think good. We're good so far, I think, Thomas.
Cool. So VS Code should hopefully be open on the screen.
Yeah, I can see it, yeah.
Cool. As I've mentioned, I've all this sitting in GitHub as well, which I'll share after as well. So let's have a look at what I'm going to be working with. I've got a Azure inspect test, pipelines folder, and Terraform folder, and also vars. Let's have a look at Terraform. So as I've showed in the sort of previous slide, we have a main.tf. And within the main.tf, I'm referencing the sort of Azure IAM provider, client configuration, the reference to it, to the backend. And then I'm going to be, in this example, I'm going to be creating a resource group, a storage account, and just deploying a simple HTML page from Azure Blob Storage. And also as well, I'm including a virtual network because I'm just going to edit that throughout my demo to have a simple change, and we can review that and look at the process going from develop, production to DR. And let's have a look at variables, which I've shown previously, or a small sample of. So everything that sits inside here that has a var dot will have a reference to it within the variables.tf. And also as well, I've hard-coded in some values which won't be changing throughout my environments. For example, address space, DNS servers. And then I'll just be adding tags as well. And so how do these variables get pretty much created, or what are these variables? So let's have a look at vars. Inside vars themselves I've got develop, DR, and also production. So if I look inside develop, I've got the same variable names here, but I've got various inputs. So storage account name, resource group name, the storage account web resource. So just a simple HTML page, nothing too spectacular. And if I move down to DR, it will have the same variables, but it will have different pretty much parameters. And production will be the same. So this is all awesome. So let's have a look at pipelines. I have multiple pipelines sitting here. But for example, if I have a look at Azure, if we go into Azure DevOps, and this is the repos. So this is a Git repository. I'm currently sitting in master. And if I look at pipelines, I should hopefully, well, I have multiple pipelines sitting here, but let's have a look in the Azure DevOps notes folder. I've got a destroy all, which we can run at the end. But for example, this is going to be a manual pipeline. If we have a quick look, there's no trigger. There's nothing to pretty much tell the pipeline to run automatically or if and when needed. And like all my pipelines, can you see that okay, Gregor?
Yeah, it's fine. You might want to zoom in a little bit. You might want to zoom in just a tad.
Yeah, cool.
Yeah, cool.
So we'll go down through the stages. The stages are pretty much similar in all my pipelines. So we've got the validate stage. I'm using tasks. You can create your own sort of bash task to run Terraform, but out of the box Terraform, there's a few Terraform tasks that DevOps provides. So I'm pretty much using Terraform tasks in installer. And so initially I'm pretty much initializing, so validating, installing Terraform if it's not there, initializing, and this is where the references to the sort of backend, or where my Terraform state is going to be referenced. So resource group name, storage account name, and then inside a container. Inside that container, it pretty much has an artifact, a file sitting there called Terraform dev.txt. And for production, it would be Terraform prod, or DR would be Terraform DR. So I've got 3 state files. and then just my working directory. And if I move on down through that, sorry, we'll move down through that a little. So we have the initialize, so that sort of stage, and then we're planning. So let's have a look at plan. And it's quite similar. So again, I have to self install, initialize, and then if I move on down, I have a new task, which is pretty much the plan. And this is outputting the plan. And inside my sort of develop, I'm not actually saving. I'm not saving at the artifact or creating an artifact from this, because it's just going to be continuous throughout until I get to production, which I will touch on after. So moving into my next stage, and then I've got things like depends on and conditions. So only run this if succeed at plan, and it will depend on plan. And then I'm pretty much running similar again, plan, and then apply. So if I go off and run this, yeah, we can run it against master, because at the moment I've actually got both setting the same, but we will just run it against develop. So currently it's a 3-stage pipeline, and it should hopefully be quite fast, because I'm running on my own engine rather than using the Azure DevOps engine. So yeah, it's going to sail through that pretty fast. So I can see I've got 3 stages: validate, plan, apply, and that wasn't refreshed. Yeah, we're on to the next stage, and then after that, it will actually apply. So if we capture the plan and hopefully everything works well, I should be able to see an output of whether it's actually going to deploy before it moves. Yep. So we can see pretty much what I've showed in my Terraform file, storage account, resource group, and also virtual network. So if I capture that, and this is sort of where you can review the plan. So plus pretty much means it's being added, minus is being removed, or equals means it'll not be changing. So it's adding in a storage account, resource group, and then moving down, you'll be able to see I'm using Azure Storage Blob, and then that's where my website is going to be stored. And then also as well, virtual network. So that's all well and good. And in the next few seconds, we should hopefully have a finish with that. So once that stage finishes, we can look at pretty much having an automatic pipeline in relation to develop. So let's have a look at that pipeline while that goes off and it does what it needs to do. So let's have a look. So I'm adding a trigger in here now, and I should have mentioned variable groups as well. So I'm referencing not dev develop. So I have three variable groups created. And the reason I've got 3 is because, well, I could have 1, but if we move down and look at here in relation to environment, I'm calling that at runtime. So the environment is sitting inside my variable group. So I've got develop, production, and DR. And at runtime, it will determine if I'm going to be which var file to use. So the develop var file, PR, or else production. So this is sort of keeping your pipeline idempotent and generic, and depending on runtime, it will deploy whatever environment it needs to or has been requested to. And in this, I'm also using full. So I've got my own virtual machine sitting there with pretty much the DevOps agent sitting on, and it's calling, or it's being called to and off and running. And then, which I didn't have before, I've implemented a trigger. So any changes into develop, it will go off and pretty much run that pipeline. And nothing else has changed here. So again, let's have a quick look at that. Yeah, so now we have develop sitting there, and a virtual network and a storage account. Cool. So that's pretty much a manual pipeline, and it's all well and good, but no one likes to do anything manually, and it's very tedious. So let's have a look at how we can automate that. So if I go into pipelines and let's take the name of that. And if I create a new pipeline, I'll go back and put it into that folder. And you can create pipelines in multiple areas. So I'm just using Azure Repos Kit, selecting my repository. So I've got a few in here. And then existing pipeline YAML. So again, it's going to be stored in the master branch. And develop pipeline. Cool. So if I save that, and if I rename it and just call that develop auto. Cool. So, okay, so nothing has changed so far because I haven't made a change to actually develop. So let's have a look in my code. So
you're going to make a change to the file, Thomas, and then this is
yeah.
going to kick off. Yeah.
Yeah. So I'm going to make a quick change. If I get Terraform and what's a quick change? For example, if I add in another DNS server, and if I go off and just add that again.
So you just commit that.
Yeah, sorry, I should have had that on the screen. I'm just using one of my other screens. And yep, so that's been pretty much changed. If I could go into develop just now, that's pretty much picked up straight away. It's automatic, so it's going off to pretty much deploy our update to develop. So that's all well and good, but for example, if I made a typo, pretty much we would have the sort of main pipeline fall over and sort of the production side of things, or if the pipeline is, if there's multiple users using that pipeline, that can be a sort of pain point. Oh, it has actually failed over. Ah, okay. The developer give TF4 does not. Okay, so this was not expected. Let's have a quick look.
Good old live demo.
Where's that calling from? Far file. Ah, sorry, I think I changed that. 1 second to hopefully fix that. Yeah, so if I go back in, sorry, 1 second. And if I open pipeline, production pipeline, yeah, I added in vars and didn't actually develop pipeline. Remove that.
You put two, yeah. I think you had two extra.
No, that's fine now. I actually didn't have it sitting inside there for some reason. Okay.
Something goes wrong.
Nothing loves a real life demo. So this has not been staged.
This is not recorded.
So let's go off and apply that again, and hopefully we should be fine now. So if I go back into develop and we'll give it another DNS server. So no, everyone loves multiple DNS servers.
Always DNS.
Always DNS. This time it wasn't, it was user, but we'll blame DNS anyway. So if I update that again, and hopefully I haven't got too excited. If I go back into my pipelines, we're automatically running again. And let's have a look now. So validate will be fine. But yeah, where was I? So yeah, for example, if myself was wanting to pretty much deploy, develop, and yourself, Gregor, and I was writing code, and you were writing code, and for example, if I typoed, that would cause this pipeline to fall over, or if I didn't, well, it would actually have caught that as well. The build validation would have caught that my plan wasn't actually correct, or the value where I told the plan to be. It still fell over. Given variables. Yeah, I don't know what is, let me see.
Definitely live demo.
Yep. Where's plan? Inside here, var files, plan. Yeah, I'm not sure why that is. Let me read that. Yeah, failed to read variables file given variables. Developed the TF4. What have I called that? Yep, it's definitely sitting there. 1 second, develop. Yeah, varval ... / environment. Yeah, I'm not sure why that is. Oh, sorry, I'm back into develop. Branch that I create that from. Yes, sorry, I know. I didn't actually put that into develop. I actually merged it into master, but I'm not sure I told it to run from develop. So we'll go again. If third time doesn't work, then
sometimes a charm. Don't worry.
I'll start singing a Halloween song. So yeah, let's have a look at validation, and hopefully I'll be able to catch that outside my pipeline. So that wasn't meant to be, but it's a good talking point. So for example, if I didn't check what I was actually deploying. So let's have a look. Okay, so that looks to have fixed that. Yep. So we're refreshing state. So that's going off the Terraform the state file to refresh the state. And from that, I should be able to catch. Yep. So as you can see, I'm adding in 2 DNS servers into my virtual network that will just go off and apply. So this is all well and good, but I want to add build validation. Or for example, I don't want to have them errors inside my pipeline. I want to have it outside of my pipeline. So during the pull request, I want to be able to tell the user that you have issues within your code. So the syntax is incorrect, or you're adding a variable and not declaring it, for example, in TFRs, things like that. So if I go back into my pipelines again, and I have a validate only pipeline. So there's no triggers in this, and it will just pretty much initialize to confirm the Terraform syntax is correct, and also plan. So I'm actually initializing twice here. And if I go back in, that's pretty much a quite a simple change. So if I go off and set a branch policy and branch validation. So inside here, if I select, sorry, I actually need to create the pipeline first. So take the name of that again. And if I go back into new pipeline, existing repository, develops notes, existing pipeline, and select, from master, and then develop and validate only. Cool. So that will hopefully go off and, well, sorry, I've actually selected that wrong. I need to go against develop again. So I'm getting very excited here. New pipeline. Develops notes, existing pipelines, develop. And I should have the city also in validate only. Cool.
So this just validates that the syntax is correct, is that right?
Yeah, pretty much, and also have a plan as well. So during the pull request, I can actually see it. It depends where you want to have your plan as well.
So the plan is going to kind of tell me what's going to change.
Yep.
Right.
So, and if I go back into repos, branches, and have a look at develop and branch policy, build validation, and if I select the develop build validation, cool. Automatic policy required, yes, and then you can actually expire it if you want. So I'll just keep that all. That's all good. So this is cool. So if I go into my code and actually, if I create a new branch, 1 second. And again, if I go off and, for example, just add in more DNS, just to show something quite really simple and quick to do. I'll actually hopefully I'll typo it, so hopefully it goes off and knows I have a typo. So this will show an error. And let's have a look. So data branch 1. So if I create a pull request and I'm going into develop and new PR. If I create this, I can add reviewers to the side myself. Okay, so no merge conflicts, but it's not letting, it'll not approve. If I go to approve, it says it has the weight in this. And so it's pretty much running the check, and you can go off and see the check. So I'm validating. Yep, so straight away that has picked that up. So if we check pipelines, the the develop pipeline is totally fine. So if I go into folders, it's maybe easier to read. Yeah, the develop pipeline is automatically fine, but you can see build validation has pretty much fell over. And if I go into pull requests, yeah, and then if I click that, I can go in and see that, again, it's the same syntax, missing item separator. So if I go into repos pull request, and if I auto approve and set up autocomplete, it's not going to work, or it's not going to actually auto approve until pretty much the build validation has been successful. So if I go in again and add in my comma to separate the value and to set up, it's pretty much picked up automatically. And so again, no merge conflicts, but it won't be approved into develop until pretty much validate. And well, plan is just for a pull request. If, for example, you were approving my pull request, Gregor, you can see straight away what I'm looking to change or add or even remove.
That's quite a nice feature, I must admit.
I'm not sure if plan has been updated here. Seems to have. So cool, it will go off in plan. Not needed for this. Cool. So if I go into my pull requests or into my pipelines, once that is finished, you should hopefully see develop auto again. So it's adding that straight to develop. Pull request. Yeah, it's just, yep, cool. So it's away merging the pull request, and within hopefully a matter of seconds, the automatic develop pipeline is picked up and away it goes and pretty much runs through that again. So that's the sort of CI/CD and or the sort of automation that you'd want to be looking within an environment. So that's all well and good. I'll sort of fast forward this ever so slightly. So I haven't got production in the bar configured yet. So let's have a quick look at production. Production, I'm looking at to be slightly more complex. So let's look at the plan. Initialize will just be pretty much the same. The plan, quite similar until after the plan output. I'm looking to archive this file. So I'm going to create an artifact, and I'm going to keep the artifact every time I'm doing or creating a new pipeline run. So if I'm doing pipeline or running 1, 2, and 3, it will have all 3 different artifacts. And that artifact is pretty much 3 different plans, or the plan it has at runtime within the master branch. And then pretty much deleting the unneeded files. And then from that, I also have a timeout as well, error in minutes, but for this environment, it's not needed. And that's a long time, I think 10 hours. So I'm not just applying this time in the apply stage, I'm actually downloading the artifact. I'm not doing a git checkout. See the way it's sitting none rather than pulling down the code again. I'm actually using the artifact that I created above and then extracting these files and then running through and pretty much running through that plan and applying the plan that I had in the above stage rather than if the code was say 2 days or 2 days newer, it wouldn't be running then new changes and then apply. So I've actually took out the stage or the test stage. I've took out the need for the Ruby version because I have it all pre-configured on my own agent. So in this as well, I'm running some inspect tests. Tonight, I'm not going to deep dive in the inspect testing. It's pretty much the Go language. So if anyone has used inspect before, it's pretty awesome. But I will show the dashboard and a quick intro into it. And also, I'm also publishing these results, and these are being outputted here using JUnit and publishing them. So there's a nice dashboard you can see within Azure DevOps as well. So if I go back, or if we look at if we have a quick look at inspect tests, so I just have 3 pre-created, one for the storage account to confirm its naming and its location. And then we can see there it's pretty much describing the zero storage account where its name should be the resource group, and also it should exist. Storage account blob, something are pretty much similar, but I'm confirming the blob container name is there, and also virtual network as well. So the DNS servers, this may actually fall over in relation to it should equal, because the syntax is, so if I add this into here, we'll see how that looks. Let's see. 1 second. Sort my branch out. Cool. So yeah, we'll push this into master and see where we end up. And then, so subnets and then DNS servers. So if I just add in a couple more into the array as well, you can start creating arrays from parameters and have a sort of generic, or sorry, it's not Go as Ruby. I was thinking of something else. So that's pretty much that. So I'm adding in some more DNS servers. And let's hope everything runs smoothly there. So if I push that into that, I'll actually need to do a new branch. I'll take the branch validation off that because it's sort of running out of time. So branch policies. And so that will allow me hopefully to deploy straight into develop. Cool. So let's have a look here. So if we go to add these pipelines, I'll just let that run, and then I will talk about production and also DR. So if I go to, I keep forgetting getting the naming syntax, sorry, pipelines, and just pull that in just to keep it nice. Yep, and where is production pipeline? I'm not going to have a branch policy or anything here. I'm just going to save that. And if I rename, and then I will actually just create DR while I'm here, and then I'll talk quickly on the DR trigger, and then I'll show an approval gate as well, which is very useful as well.
So, running a little bit short on time, Thomas.
Yeah, sorry. DR pipeline, that's there. So yeah, rename. So that should all be well and good. And for example, if I do a pull request, I'll have that sitting there as well. And cool. So that's all the changes that I've done. And let's see how this goes. Yeah. Okay. So that should, yep, so that's going to kick off production. Sorry, 1 second, I'll actually cancel that just to show an approval kit. If I go into environments, I'm running through this very quickly. I actually have a blog in this. So, I'm using the wrong one. I think that should be it. Approvals. Nothing. So this here is pretty cool. So if I actually just run production from the automatic itself. So yeah, this hopefully shouldn't take too long. And then this should, if we go back into DR, once this is run successfully, it will go off and actually just deploy DR as well. The source is probably going to be different. Yeah, we'll actually not show that because I'm running out of time. So I will pretty much show the approval kit, and then I'll move in. I have just a couple of slides and recap what I've done. And then also as well, I just have a simple Linux agent configured, and it's running through everything. So it makes it a lot faster rather than waiting on pretty much the hosted agents within Azure DevOps. So this is going off and deploying. I'll show inspect testing and I'll not worry about DR. Cool. So this is all good. And yeah, so edit stop. Okay, so I have an approval sitting here. And I can review up here. So I want to see what I'm planning. Okay, so I'm just pretty much deploying the full environment. So this pretty much puts a blocker and doesn't actually deploy. So if I review and all good, so you could have your stakeholders reviewing the code before it goes into production. This here should go off now and deploy, and then quickly I'll show inspect. I'll actually go through the slides and then I'll show inspect. So if we go back, just looking at the slides, I'll go through these relatively quite fast. Yep. So where did we start? We started pretty much from a manual trigger and develop, just a simple Terraform initialize plan and apply. And then we added build validation. So that's pretty much a favorite of mine. It validates the code by pre-merging and building pretty much the pull request changes. And you can see if there's any sort of syntax errors or the plan isn't going to be what you expected. And created a branch policy. So pretty much it runs a CI pipeline to validate Terraform code along with the plan during the pull request phase. So that keeps your main pipelines clean. And testing what you deployed. Inspect the Azure. It's a resource pack provided by Chef that uses the Azure REST API to allow you to write tests to resources that you've deployed within pretty much Azure. And it's open source framework, and it's really, really good. So I recommend you having a look at that as well in your own time. So if you have a quick look, you can see it outputs a nice dashboard as well on a good day. And so the finish, the multi-branch pipeline. So we started from a manual pipeline and develop, and then we moved into sort of develop, production, DR. So from one environment to another, and pipeline triggers are great. So start from dev and end up in DR, all from a matter of just the same sort of pipeline structure. And remember to test that infrastructure. So key takeaways, Terraform, it's readable and very user-friendly. Hopefully this is the beginning of your CI/CD deployment journey and overview. Use triggers for automation and begin testing your code outside your initial pipelines. Inspect testing is definitely a great addition. And hopefully this gives you an urge into more of Azure DevOps. And if you're not using it already, I recommend you having a look. And sort of blog plug here. So whatever I talked about tonight, I find it more in depth into my blogs and also the GitHub repo as well, if you want to run the Terraform or look at the pipelines as well that I use tonight. And Gregor, do you want to?
Yeah, just really quickly, we've got some Azure resources. I know we're running out of time, but there's a cloudfamily.info website, which has got lots of Azure resources in there. So yeah, I'll just move on, Thomas, to be honest.
We're well out of time. So I'm not sure if anyone's any questions. I think I spoke a little too much and
no, that's fine.
Left them.
Cool. We can answer the questions on the chat.
Yep,
sorry about that, Liam. All good. Thanks, Thomas.
Yeah, no worries.
Perfect. Well, thank you very much, both. Are there any other outstanding questions for Thomas and Gregor at all at this point? I'll just give it a moment for the live chat to catch up.
Yeah, so I've got a quick question. So a lot of the stuff I've done with DevOps, I've been using the releases pipelines, which at the moment are still very visual, drag and drop, no YAML support. Am I right in thinking they're going to be deprecated in favor of using the pipelines for doing releases? Is that?
They already are deprecated, I believe.
Are they? Right, okay. I wondered why it hadn't caught up with the YAML.
Yeah, YAML's definitely, well, it depends on your use case, but I definitely recommend using sort of Azure pipelines, YAML, depending on the size of your environment as well, or what you're looking to do. But pipelines.
Sorry, go on.
Yeah, no, sorry. The pipeline YAML, it can be quite complex as well. So depending on your resources as well, and the sort of time needed possibly to transition from what you have in releases into pipelines via code, it might be worthwhile. But
the pipeline YAMLs at the moment for doing the build, test, package up Docker containers, that sort of thing. And then I trigger a release on the release pipeline side, which will then actually do the deployment side of things.
Yep.
So I kind of got the two working together, but yeah, I guess I could move the release stuff back into the pipelines with the other bits and pieces.
You could still have that separated process if you wanted to, David. So you could still have a pipeline that does the build and then a YAML pipeline that does the release. They don't all have to be in the same pipeline if it makes more sense for you to do that.
Yeah, sure. Yeah, no, I think from my original days, it was kind of, they were sort of very separate. Like, yeah, there's like build and release, if you see what I mean.
Yeah, sure.
Yeah, cool. No, thanks. That was really good to see.
I've got a quick question, if you don't mind. So there was a number of statements you made throughout there regarding a lot of your scripts being similar, or it was similar to a previous step that you'd shown us. And I was wondering what kind of opportunities there are for code reuse. So, are there things like inheritance or transformations that you can apply so that you can reuse some of this stuff more readily?
In what aspect, sorry? In relation to the pipelines?
Well, in particular relationship to your Terraform code in your YAML files.
Yeah, depending on the size of your organization or the environment, you probably want to sort of look at modularization. So, for example, if I was doing a module for virtual network, I would include all the resources that I would need within that virtual network. And once I've created that, I could reference that module in 10 different environments and have the one sort of source of truth.
Okay, thank you.
You can also reference, so you can have like a template that's referenced from other templates. Is that right, Thomas?
Yeah, that's where I'm going down the sort of modular route. What I showed is quite high-level Terraform. If you're writing Terraform for an environment, you'd most likely want to modularize, and then multiple teams can reference the same module. For example, well, I'll use virtual network again. One team may want the virtual network DNS to this, the other wanted possibly to be that for a different environment. So if you have the module sitting there, the same input each time is going to be inputted the same, but the DNS servers and things like that can change.
Okay, in terms of that modularization then, do you have any guidance regarding how you cut up your infrastructure as code into different repositories? How do you group things together? What sorts of rules would you put? I guess from an application point of view, I would normally think around things like package cohesion. How would you sort of apply that to infrastructure as code?
Okay, yeah, well, if what you want to package inside a module, it really depends on, you probably need to sit with your team and determine what you're going to declare within a module. A lot of teams I've worked with as of recent times, for example, the networking could be all one module, or a different team could have multiple segments of that module or reference that. But then in relation to sort of, were you looking at the segregation of that?
Okay, thank you.
I got a question related to Terraform.
Yep.
Have you got any experience in using import modules? I mean, when you start a project from scratch and you build all the...
you can sort of import your Terraform state. Is that where you're coming from?
Yeah, so for example, I mean, there will be situations where even if you want to use Terraform, there will be part of the infrastructure that is already exists, and you might not be able or have the luxury to tear it down and recreate it with Terraform. I mean, have you ever had some kind of gotchas where you were trying to, I don't know, I mean, I come from more like an AWS background where, for example, you don't want to delete the Elastic IP because that is being whitelisted with an external partners. Does the Terraform import modules work well when you have to almost like take ownership of existing infrastructure?
Most of the time, yes. It depends on the complexity of your environment, but sort of importing or increasing the initial Terraform state, that would be a different discussion sort of altogether, which I haven't showed in this. I showed just an overview of pretty much Terraform. But yeah, it depends on the size of your environment as well. It can be relatively slow sometimes as well, if the environment is quite big. And then from that, I recommend looking at various plans and things to confirm that it's pretty much brought it into the start state before you overwrite or bring Terraform into the equation, or Terraform changes into the equation.
Cool, thank you.
Perfect. So, folks, think we'll wrap up there. So, a huge thanks once again to both Thomas and Gregor. So, big round of applause for those guys.
Yay! Woo!
And so, last couple of things whilst we are wrapping up. The first thing is, Misha, do you want to do the prize draw?
I do. I will do the honors. Thank you. Right. So who's going to win a JetBrains license? Drum roll, please. Well, I'll do it myself. It's quite difficult to do. And the winner is Cloud Hubs, who was excited to watch Gregor Gregor and Thomas present Terraform using Azure DevOps. So well done, Cloud Hubs. I don't know who you are.
Fantastic. So if we'll reach out to you on Twitter, and we'll sort that handing over of the license. So last couple of things then, so let's just quickly wrap up. So again, huge thank you to our three speakers this evening. Mark earlier on this evening talking about building choreographed microservices systems architectures with lessons learned there. And you will have just been listening to Gregor and Thomas talk about deploying Terraform via Azure DevOps with a lot to take in and learn about there. This video will be available on YouTube right now after I press stop. And we'll tweet out links to that as well. So if you've missed anything there or want to run back through anything, that will all be there. And a little bit of two things of self-plugging. You can see that Peter's joined. We did our first premiere of Azure-ish live today, where it was basically, if you've ever watched Scrap Heap Challenge or Junkyard Wars, it's kind of like that, but then we're building it with Microsoft Tech and Azure. We've started building a Git watcher, in which we're going to carry on doing that. It'll be airing every other Tuesday. So we've just done one today. So the next episode of that will be on the 10th of November. You can see that on twitch.tv/Azure-ish live and follow us on Twitter and stuff like that as well. Another thing is on Thursday morning, I will be talking at Knott's TechFest to talk about just what is DevOps anyway. And other than that, our next DevOps Knots will be on the 24th of November. Same time again, we've got DevOps Derek coming to talk there too. So thank you once again, folks, for coming. It wouldn't be possible without you folks. So we shall see you all again next time.
Yeah.
Thanks, everyone. Bye-bye.
Thank you. Thanks for coming.
Thank you, guys.
Bye-bye.
Cheers.